What's up? How's it going? Alrighty, let's see if this works. Let me send over the link to y'all. 1 second. Can y'all hear me? Can y'all hear me?
Yep.
Awesome. Sweet. Thanks. Good. Alright. Here we are. We are live. Here's the link. Here we are. We are live. Oh god, that's me. Here's the link. Here we are. We are live. Oh god, that's me. Here's the link. Okay, cool. Awesome. Good. And then you should all want to try to mute your sound over there. And let me see where Dom is right now here. Are we missing anyone else? Let's see. We got Angela, Anthony, Jeffrey, Mady. Missing Dom. Dalibor may be off too. You can all see the screen, right? Oh, that's actually quite small. Interesting. Let me see if there's a if I move it to the side, do you get more room? Were we trying to say something? Feel free to talk now. I'm gonna be missing. Oh, okay, no, she's gone. Hey, Dom. Okay, nope, just cuts out the sides for some reason. That's weird.
Hey.
All right, cool. Can you all see like the text and all that? It's all readable for y'all.
Where's the link?
Oh, it's in. Oh shit, my bad. Whoops. It is that Bootcampers thing right there. Cool. Awesome. It's in general. It's in.
Yep.
Awesome. Cool. Everything's clear to you. You can see it. Cool. If it's readable, that's good.
Can you make the text larger?
Yes.
I can't really make it full screen. I only have one monitor.
Yeah. This is it's not a monitor problem. It's just that it's a problem on the fact that YouTube only has so much space. So I do have like a second monitor where I'm like showing all this, but it just won't show up. Okay, so the text in the code editor is what you want larger, right? Let me adjust that.
Yeah.
Cool. Is that a little bit better? Let's see. Then let me just see if I can make that. And let me just see if I can make that larger on the side. Let's see. It doesn't appear that I can figure out how to do it right now. If you like zoom in the screen, like, can you see the text? Is that readable or no?
I can read that, yeah.
Okay, cool, awesome. Sweet. Good stuff. Alright, let's see. So we've got, Angela's gone. Oh yeah, she'll go to sleep so she can, okay, cool. Alright. Good, Dalibor, you're here too? You can hear us, Dalibor?
Yep.
Awesome. Good. Alright, cool. So we're gonna get started then, and that should be everybody. Might as well toss in my live webcam so you can all see me. Let's see. Here's my video capture device. There's my face. It's where the hell did it go? Shit. That's weird. 1 second. Yeah, there we go. Cool. No, fuck it, it's not working. Okay, whatever. Shit. Alright, cool. So today's lecture is... Oh, here we go. Good. Alright, that's my face. It just took over the whole screen. Cool. Alright, so today's lecture is going to be on Mutability and Ruby style. And so you both... All of you should have done the lecture readings already. So the lectures generally are a time for you to kind of get mastery and like ask for clarification if you have questions. And so I'm going to talk a little bit first about how we're going to go through these lectures and what you can expect from them and how I want you all to interact with these lectures, in fact. And so again, like all the material that you need to get through this course is already in the online stuff that you see, right? So there's nothing new in this. This is just, again, a time for all of you to get additional benefit in asking specific questions that you might have, right? That are relevant to yourself and to others. And specifically, we're going to go talk a little bit more in depth about some things that do trip up a lot of people and that are kind of helpful and that you may have already seen. In fact, I think I did see a lot of you struggling with some of these things in, for example, my flat and so forth. And so a quick kind of refresher is, if you don't understand something, ask a question, right? Don't go overboard. Don't try to interrupt like all the time and like ask like questions every 5 seconds because, it is your time multiplied by like, 6 other people. But generally, none of you actually ask enough questions. So I would encourage you all to ask many, many questions. And in fact, I'm going to call on a bunch of you over time to answer interactively kind of a lot of the stuff that we're going to go over. And yeah, chances are, if you have a question, other people also have the same question. So people are going to generally very much value the questions that you have. So don't think that any question is like a stupid question or too simple or too silly. If you do not understand something that I'm talking about, you have to tell me, right? So that we can clarify. Chances are other people also don't understand. Okay, so let's talk a little bit about the lecture goals for today. So first, we're going to talk about mutable and immutable objects in Ruby. And then I'm actually going to ask some of you to try to explain that. And then we're going to talk about how to initialize hashes and arrays with default values correctly. And there are some pitfalls here. You may have already seen these pitfalls as you work with this, but we'll discuss them. And then we're going to learn good Ruby code style and practices. I've seen some of you better than others with this, but it seems like generally it would be helpful for all of us to have a good review here. And we are going to talk about class methods versus instance methods very quickly, very shortly. That is just a small thing. But first, can anyone tell me what mutable objects versus immutable objects are in Ruby? Dom? Or maybe?
Yeah. Mutable objects are objects that can essentially be mutated. Immutable objects are objects that can't be mutated. So a perfect example would be any regular variable as opposed to a constant.
So can you explain what you mean by mutation? That's totally correct, but go a little bit more into.
So, I mean, I could be wrong here, but mutated in the sense that at the memory of the object ID, at the memory ID of the specific object, it can be, it could be the value could be adjusted. It can be modified. Like, say you have a variable, say you defined val, and val was essentially a string, and you can change it to an integer. That will point to a new memory address, but it's still something that can be mutated. Immutable objects, you can't do that.
Yeah, you're definitely, you've got most of those points totally correct. I'd say maybe like a better thing is just to say, specifically with Ruby, we're keeping it a little more simple at this point in the sense that we're talking about what kinds of objects in Ruby are mutable and what kinds of objects in Ruby are not mutable. But you're totally right. It's things that, that you can actually change in that, place of memory where the object
But
is
you're
stored.
totally right. It's things that,
Dom, you have my, Okay, cool. Dom, your YouTube video may actually also be on, so you might want to shut the sound off that if you're getting that feedback. Did you have something you want to say? Cool. All right. Anyway, yeah, so basically a mutable object is, an example is like, for example, a string, right? We'll talk about this more later.
Yes, I'm not sure. Where should I watch the video so that there's no feedback
Links
when
in
I
the
have
chat.
both Discord and YouTube on?
Well, turn off the sound in your
Okay,
YouTube
so
video.
I have, one sec, so I'm going to unmute you.
So just mute your YouTube channel, dude. If you load the link in
Or maybe I
Chrome,
should just
mute.
get like headphones or something.
Wait, no, Dom, you can literally just mute the YouTube video, right? Can you do it?
But how would I? Oh, Jesus, of course. Yes.
Yeah. It's okay. Sometimes
Great
it's
idea.
obvious answers that
one sec.
aren't easy.
But how would it? Yes.
Wait,
Because
you're gonna hear me talk through Discord, right? And then so you'll hear all the sound through Discord, and you'll mute.
Exactly.
Yeah. Okay. Cool. Awesome.
Yes.
Yep. Awesome. Yeah. Okay. Cool. Did you have a question, or was that it?
Oh well, actually, I just want to say that like integers and like nil are immutable, and like strings and arrays are mutable, and like yeah.
Exactly right. Exactly right. Yep. Yeah. So an integer in memory, like 1 is just stored in one place in memory, the integer 1, right? And like that will never change, right? You can't ever change that pointer in memory to any other like that memory address to anything else. Strings and so forth, like arrays, hashes, whatever, right? Those things you can actually change the values that are actually stored at that address in memory. So there's a huge difference between mutation and assignment, which we're going to talk about a little bit more. But that's a good starter for sure. Good. Okay. So let's talk about references in Ruby. And so objects are stored in memory, right? You all kind of should have had this reading. Does anyone want to try to explain that? Let's see. Dalibor, did you do the reading?
Nope.
Okay, cool, awesome. Anthony, you wanna try to talk about a little bit about like what we mean by memory and pointers and references? Anthony?
Yeah, so sure. I guess one thing is like if one thing I was reading about in the notes was that if you create like a variable and then you set that equal to another variable that in the same spot in memory, so and depending on whether the data type is mutable or not, like if you change one of them, the other one could be changed as well.
Yeah, that is a super good start. Yeah, so basically, right. There's a big difference between, okay, so basically variables, let's talk about variables in Ruby first, right? And so variables in Ruby do not actually store any kind of like object themselves, right? And so in some languages they kind of do. They don't necessarily hold references, right? But they are themselves like, the pointer to the not necessarily the pointer, but like the actual the thing they reference the thing themselves. But in Ruby they are just pointers to a place in memory, and then that place in memory, that memory address, is what actually holds a actual object, right? Like a string, right, or a part of an array and so forth. And then in that place in memory, you could do something like this. Let's try writing some code. Actually, I'll just do this in Pry. Hopefully, you can all see this. And so let's say we have a, and we set it equal to hello. And you may have all seen this before, but there's an object ID kind of a pointer right here, so you can see that. So this is a huge little number that just popped up, right? And then we can do something like b equals a, right? And then b actually also points to, you can see the exact same, this is like the memory address, right? And b is actually just a pointer to this memory address, this object ID. And so you can see they actually point to exactly the same thing. And so there is a little trick that we could do here, right? Like we could do a0 equals b, right? And then what does a equal? A equals below. But turns out b also equals below, right? And so that's because these are not two, like, people get confused here, right? Because they think, oh, like, b, we set it equal to hello, right? And so, like, if we change a to below, like, b should still be hello, right? But in fact, we didn't, right? We actually said, let b equal the same object that a points to. And so b points to the same object in memory. There's actually only one object that they both point to. And so that's where the problem lies, right? And when you aren't aware of this, you get really weird errors in your code, right, that you don't understand. And so this is a super, super important point to conceptually understand and really like grasp. And there are some differences, like there are some immutable things, and we'll talk more about this in the future. But if we set a equal to this right here, and then b equal to a, and so forth, these are symbols, right? And so you may have seen symbols in your code before. These, again, still have the same pointer, but these are immutable, right? They cannot be changed. And so I'll show you some differences between this in a second. Let's do hello here, and then we'll do d equals c dot dupe. Okay, so you may have seen the dupe method or the clone method. They change for a mutable object, what they do is you can see their object IDs are actually different here, right? So if we do the same thing that we did before, and we set this equal to B, right? And then we look at D, we see D is still hello, B is below, right? And so what we did here is what we said is, okay, this is like a mutable object. We don't want you to actually point to that exact same object in memory. We in fact want you to duplicate that object and copy it somewhere else and then point to that instead, such that if we change the first thing that we kind of made, it doesn't change that second thing that we now point to, right? And so that's kind of important, right? If you and you've seen this, I think some of you, like Matey, you may have had this problem in your code where you're mutating the argument that you passed in, right? I think you had like a def my reverse kind of thing, right? And then with your reverse, what you're seeing was that you're actually, or it was like a not reverse but rotate, right? My rotate, and you're like rotating an array, and as you rotate that array over time, you could see that like as you called it multiple times, right? You had like 4 prints down here, right? You had like rotate 1, p rotate 2. And then the first time it worked fine, right? But then like over time, you're like, crap, like why is it not working anymore, right? But it was in fact working. The problem is you're passing in the same like array to each of these, right? And the problem was that array was being fundamentally changed every time that you like worked on it, right? So you were doing something like let's say this goes like, this is a monkey patch method, right? So like class array and then in here what you have is like the num of rotations, right? Num equals 1, and then you're doing something like for while like up till num, right? Like let's say 1 2 num dot each do, or we could do like num times or something like that. Anyway, you would do like you were doing the rotation pop here or something, right? Like self dot pop, and then like self like push that var equals self dot pop, and then you would move that into the you're popping from the back, you're moving it into the front, right? So you're like shifting it over. So self dot shift unshift the var and so forth, right? Or L. But yeah, but as you can see, like this code, what this was actually working on is it was directly working on the array itself, right? And so as you go through this, the array fundamentally changes, and as the array changes, then this stuff is going to be totally different over time. So let's why don't we take a look here? Let's see if we can see what's going on. Ruby lecture 2. Okay, so we can see this this shifts, right? This shifts the 3 at the back to the front. But then if we just do this right here like so, we can see, what does this do? This shifts 2 over, right? So we get 3, and then we get 2, and then we have the 1 at the back, right? But now what happens if we do both of these at the same time? Do we get the same result? And we don't, right? In fact, okay, so now it shifts this over 1, right? But then this result is fundamentally different from this result, right? Which is really weird, because when we ran this by itself, it worked fine, right? But then when we like ran both of them, it like gave us a completely different result, and it's like really weird. We only wanted to rotate 2. Why did it do a full rotation all the way back again, right? And the reason for that is, again, of course, because we are fundamentally mutating that array, right, when we're doing this pop and this unshift. And if we wanted to not mutate this array, we would actually have to return a completely new array here, right? So what we could do is like new r equals self.dupe, right? And then if we do that, we can just change all this to new r, right? In fact, let me just let me do Command D, by the way, if you guys aren't familiar with that, is how you just like do a bunch of lines at the same time, so it's a lot easier. Cool. Now we take a look at that, and look at that. Now it works perfectly, right? And so this is a really important thing for you all to know, is if you were to do a mutative method, that's cool, right? But make sure that's what you intend, right? And you do that by putting a bane at the end there, right? If you don't want to mutate your you should generally never mutate your arguments unless that is what you intend to do, and that is made clear to anyone who's going to use your code that your method is a mutative method, right? We'll talk more about this in a second, but basically you do a bane at the end here if your method should be mutatable. But if it's not, then like, yeah, don't put that in there. Make sure you're not actually changing the thing that you're passing in, or the the monkey patch kind of thing that you're calling this method on. You should actually just like dupe it, right? And so dupe, again, it kind of duplicates that array with a new array at a completely new place in memory that you can change without fear of like screwing up the earlier one. However, there is a big catch here that we'll talk about later, specifically with like arrays and hashes and even strings and other things that are mutable that hold other mutable things inside them. There's a big catch there. Cool, awesome. But yeah, so last point on this slide is the assignment operator, right? So equals is a assignment, and so it's very important that you don't think that this like rewrites the memory address that the thing used to point to before, right? So if we go back here, and let me just clear this right here for y'all. Okay, cool. So if we do a equals hello again, and then we do b equals a, and then we've gotten, you know, again, they point to the same object in memory. Stop me at any point if none of this makes sense or, you know, something's confusing, I'm going too fast, whatever. But, okay, so now that we have them at the same object, now we're like, okay, let's rewrite a, right? Let's do a equals like goodbye, right? Cool. Did we actually overwrite a? Now does like what a points to goodbye, what does b point to? Anyone want to tell me? Jeffrey? Yeah, you're muted.
B still points to hello.
Awesome, awesome, awesome. Good, perfect, good. That's exactly right. B still points to hello, and so again, because they don't point to the exact same, like this is a reassignment, right? So what did this A do right here? Well, actually just changed the object in memory that A points to. It didn't actually change that original object that A was before, right? And you can see B is still that exact same object before in memory, right? And so if we do something like A0 equals H or something like that, obviously it's not going to change. Goodbye is not going to change B whatsoever, right? So that's really important to know, and we're going to talk a little bit more about that in just 1 second, is that when you use the equal sign on anything, right, on any variable, it's not going to change what you had before that variable was pointing to at all. It's just going to assign that variable to a completely new object in memory, right? Cool, awesome. So yeah, you all touched on this basically already, which is good. Mutable means that the object can be modified after it's created, right? Immutable means that the object cannot be modified after it's created. And everything in Ruby is an object, right? It's a really like strongly object-oriented language. And so a string, for example, you can see on that mutable slide, right? Strings, arrays, hashes, they're all objects, they're all mutable. Integers, floats, and symbols are immutable. These are just some examples of things. And so for example, here, what we can, I'll show you like what the difference between a symbol and a string is, right? And so let's say, again, we'll do...
Quick, just,
Yep.
just do it like, no, I have a question about like, can I ask a question? Is that cool?
Yeah, of course. Yeah, please.
See, like the way I visualize memory is that it's like a box with a bunch of sections, and like, for example, one section has like hello in it, like a string hello, another one has goodbye. What if it's like a huge paragraph of like a string book or something? Does it, the memory already had that string, or do we create that sort of section as we're making that Shakespearean book?
Okay, wait, so if I understand your question correctly, you're asking like, you know, these boxes must have some like fixed amount of space that they can hold, right? And so if we have like a massive like thing, like our string is like a gigabyte long or some shit, right? It has like, you know, millions and millions of like words or something like that.
Or even just a word, like even just, I mean, even just a paragraph. Like if we say A equals to a string and just like some, I don't know, like, does that mean that the memory already had that sort of version characters inside of it, and then we just point to that? Or, I mean, like alphabet, like letters. Or do we create that section as we're a variable to that like section?
Yeah, that's a really good question. Strings are specifically, yeah, there is actually no like specific like data type of a like a fundamental data type of a string. Strings are basically in Ruby. I'm fairly certain about this. We should check this later though. But like they're basically like arrays that hold characters, right? and each character is actually like stored in like memory, and basically a string just points to all of those, right? And so if you do have like you can see here, right, like we can like index into a string very similar to the way that we index into an array, right? And to like clarify your question both on like that side, let me know if I don't fully understand your question. It wasn't exactly clear to me, but basically, yeah, for arrays and strings both, like they just hold a bunch of characters or elements, right? And each of those characters or elements is a place of memory, right? And then like the string basically just like holds pointers to all those different things, right? So that's why you can have an arbitrarily long string. What's up?
That's really cool. Yeah. Okay. Yeah. That's awesome.
Yep, exactly right. Yeah, that's a super good question. Really good. Yeah, so there's like there's a good CS50 lecture that I can like point you to later that talks exactly about this, right? Like a string is not like a thing in itself, right? And that's why you can have arbitrarily long strings, right? Because they, like you can have arbitrarily long arrays, right? They do just like point to like, you know, a very like a varying amount of like other objects. Yeah, super good question, and that's something else that we should talk about with like integers and floats and symbols and so forth, right? Is that like with integers and floats, they do not have like infinite memory storage, right? Because they do in fact like have a finite length that they can have, and they used to have this thing called big num, and big num in yeah, big num is deprecated now. Integer now is like this whole thing, but basically like there used to be like big nums and small nums, right? Like small nums, which are your normal integers, could only hold up to so much data, right? And then like big nums could hold way more. Here, let me do this. Just talk a little bit more about this. You can see, okay, so remember when we did things like this, right? This is kind of interesting, right? And then we can do like c.objectID. Whoops, c is not defined. Okay. c.objectID. Hey, you can look at these, right? These are all their object IDs, and you can see that they're really, really different in like how long they are, right? In fact, like this first one for this integer is just 3, and then for the symbol, it's like, you know, like 2 million something, right? And then like for this like the string, it's like 7 billion or some crazy number, right? Or like 700 billion, who knows? 3, 6, 9, yeah, it's like 70 billion or something. But anyway, like these are really, really like different. Can anyone like guess why these might point to such different places in memory? Jeffrey, you want to give it a shot, maybe? Or anyone else?
Is it because of like ones and zeros? Is that like one is made of like less ones and zeros?
Not quite. Actually,
Sorry, I have to go to the bath.
Oh yeah, no, you're totally good. Yeah, not quite. That is a good guess. These are actually arbitrary pointers in memory. I could show you this. There's a really nice kind of walkthrough of like actual pointers in memory that someone made for C. Let me see if I can find that actually. Mini C. Shit. Anyway, but yeah, not quite. These are actually totally arbitrary points in memory that like. But the basic idea behind this is because these things are immutable, you can start storing them at like earlier places in memory that like you don't have to like constantly like just store for arbitrary things that you're gonna have. You know that like you're gonna always be using like integers in your code, right, and so forth, and like so you can just store it like at the very beginning, basically. You can see actually 2.objectID is at 5, and in fact every integer, yeah. Lorraine, feel free to keep go into more detail about this if you want. But you can see that these integers just go up incrementally by 2 every time, right? And this is true of like all these integers, right? Like they're just stored at these like earliest places in memory. These are just like basically partitioned off for these integers. Whereas for things that you're going to arbitrarily create yourself, they're stored a little higher up arbitrarily, right? This is just an arbitrary place that Ruby decides to start storing like your symbols and so forth. And so you can see if you make another symbol, obviously you are creating these, right? So unlike integers, which are just like these constant things that you're always going to have, like you are creating the symbol, right? Like it's not going to magically put in like we in like your code like without you telling it to. But certainly the trick here with a symbol is, you know, we can say d equals we, right? And so this is interesting because, for example, if we do b equals hello, and then we do e equals hello. Dom, can you tell me, do these two things, b and e, do they have the same object ID? Are they pointing to the same string in memory?
Wait one sec.
What's up?
Wait, so does B and E?
Do they point to the same object ID? Yeah. So if I do b.object ID equals e.object ID, will that give me true or false?
True, but since you're asking, it's probably false.
Yeah, exactly. Good meta strategy for answering questions there. Yeah. So can now I'm just gonna, sorry. Go ahead.
I have a joke. They should have put "Hello World" as one of the numbers because everyone uses "Hello World." Ha 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 ha.
Good stuff, man. All right. Anthony, do you want to tell me if a.object ID might equal d.object ID? If I do this, is it going to be true or false?
I'm going to guess true because the symbols are an immutable data type, so I'm going to say true.
Really good call. Perfect. Yeah, you both got it right. Even if you might not 100% know why you got it right, you did get it right, so that's good. Yeah, so that's exactly right. And the reason for that is when you do an assignment to a string, anytime you do that, it's just going to, these are mutable things, right? So it's actually going to create a completely new string for you. And so like e.object_id and b.object_id are totally different, right? They're completely different things. But with symbols, that's an interesting thing. Whenever you create a symbol, anytime you ever create another symbol that like points to that same value, it's going to point to that exact same object ID. If we do like a, let's see, delo equals we, and then we do delo.object ID, these are completely random things. You can see it still points to that, right? If we do dot equals hello, you can see that whatever that is also going to be a completely new object than the ones that were here before, right? And these are kind of hard to tell, but these are in fact different, right? This is 4416. This one's like a 51360. Anyway, okay, cool. Hopefully that makes sense. Let me know. Stop me again if it doesn't make sense to you. But basically that is the difference between like a whoops. Oh god, let me stop that real quick. Yeah. Okay, cool. Yeah, so that is the difference between a mutable and immutable object. And guess what? It might be the same for integers. So why don't we try something like that? Why don't we do a equals 1 and b equals 1. Now, Dalibor, you want to tell me if you think these object IDs are going to be the same or different? Dalibor, you're muted and you're deafened for some reason. Yeah.
Well, I'm listening you on YouTube. It actually makes sense for me to. I mean, because your screen is late, right? So it's kind of messy. Yeah, it should be the same.
Awesome. Can you say why?
Because it's integer and it's not mutable.
That is exactly right. That's really smart, man. Good stuff. Yeah, perfect. Yep. So these both have. Let's say Matey. Do you want to tell me what object ID we're gonna see for B here? Matey?
Oh, sorry, hitting the wrong broadcast button. It should be different, right?
No. Like, what is B.object ID? What does that equal? What's the object ID that we're gonna see there? You have any guesses?
Wouldn't it be the 256.0028?
No, that is pointing to a string. B is B equals 1, right? B is just the integer 1.
Oh, I thought you wanted the object ID that was up there.
Yeah, the object ID of B. Yeah, that's exactly what I want. Do you happen to know what that is?
No.
Okay. How about you, Jeffrey? Do you know? We're gonna go up and see if anyone knows.
Wouldn't it be a new object ID?
Wait, what?
Would it be different object ID than previously? Because when it's equaling 1, it's not equaling the same. Like, is 1 just a place stored in memory that always
Yes.
points to 1?
Yes.
Okay.
Yes, we did in fact talk about that. Did
I think that's
pay
It has
attention?
the same object ID as A, so.
Yeah, that is true. But what is the object ID, Anthony?
Wait, I paused your screen.
Okay.
It's 2 or 3, but I don't remember. It was like double
one
what
person at a
the
time.
number
One person at a
was.
time. Okay, everyone stop talking except Anthony. Anthony, go.
I think it'd be like 2 or 3. It was about double what the number was in the previous examples, but I don't remember exactly. But I would guess 2 or 3.
Brilliant. It is 3. It is exactly 3. Good job, Anthony, for paying attention. Okay, all of you else, pay more attention.
I think I was in the bathroom.
I said 3 instantly.
Good excuses. Stop going to the bathroom. Okay, cool. So basically, B is equal to 3. A is equal to 3 too. If you scroll up and you see, we talked about this like right here, right? Remember I was like doing the object IDs of integers, and I said that these are like always fixed, right? No matter like what Ruby you're running, like it's always going to just like anytime you key into the object ID of like 1. Oh, okay, good. Good job, Dom. Good job. Dom and Anthony, you two are good. Everyone else, you guys should improve your listening skills. Good job. Okay, cool. So basically, yeah, they are just like they are always fixed, right? And so, does anyone want to tell me this? Can anyone guess what this is going to be? What's the object ID of D? Anyone know? Dom.
Wait one second.
You said you got the last one. You should be able to get this one. Put you on the spot.
I just trying to. Hey, this isn't count.
It's cool, man. It's super predictable though. Basically, all these integers, they go up by 2 at a time, right? So 2.objectId is going to be 5. 3.objectId is going to be 7, so forth. Exactly right. Yeah. But basically, like that's the thing is like you can predict these. There's actually a thing called pointer arithmetic, which is actually quite useful when it comes to arrays. But I mean, like you could theoretically do it here too, right? Like it's really easy to figure out wherever an integer is actually stored in memory. At least these like these relative pointers that Ruby gives you, because you literally can just add 2 to that integer, like for each integer that is, right? And so like you would just do integer times 2 plus 1, right? And then you would get basically whatever that is, right? So does someone want to like do this like totally unnecessary last like example? Does anyone want to guess what this is stored at? Was anyone paying attention? Jeffrey? Maybe?
So what?
Are you asking what D's stored at?
Yeah, what E is.
Oh yeah, 7 for sure.
Wait, no,
E, what was E?
E is
What
50.
number was E?
E is 50.
E is 50. 101.
52.
Good shit. Okay, you guys get the idea. Okay, good job. You were paying attention. Good. I'm just checking to see if you're all paying attention at this point. Like
Yeah.
this is not like particularly important for your lives. All right, cool. Okay, so this is just a quick idea of like, again, this idea of like these boxes in memory, right? And like how things work. This, we're giving an example here of like an actual array. And so basically, let's make 2 arrays here, okay? Let's do nums equals 4, 5, 6. And then we'll do other nums equals nums, okay? And so at this point, who wants to tell me, and this is refresher at this point, all of you should like totally understand this by now, hopefully. But Anthony, is this true or false? What I just wrote, nums.objectId equals other nums.objectId.
I think it's false because arrays are mutable.
Nope. It is true. Yeah, Dom, you want to explain why it's true?
They point to. So like as the way I visualize it is like the section points to an array. Section.
Wait, what do you mean by section? Sorry.
Like in the memory, like if the memory is just a bunch of sections. So they point to the same section, and that section points to an array which is 4, 5, 6.
I mean, yeah, that is how memory works, kind of, but that doesn't necessarily explain why like nums and other nums are equal. Lorraine, you want to explain? All right.
I understand. Like I see what you did. I see what you did. You didn't create them separately. You set other nums equal to nums.
Exactly right. Yep. So can you explain why that did not like do false? Why that gave true since I did other nums equals nums?
Yeah, I originally thought you created them separately, but set two different arrays equal to 4, 5, 6. But you set one array to point to where the other array already was created at, so that's why it would be true.
Exactly right. Yep. Super good call. Yeah. There's only one array in memory right now that we created, right? At nums equals 4, 5, 6. That's where we created an actual array in memory, right? And then when we did other nums equals nums, we actually just pointed the variable other nums to that array that nums points to, right? And so we never created another array. You can see their object IDs are exactly the same. Good. Okay, so that was just refresher at this point, but all of you pay more attention. Good job. Okay, so basically now let's talk about like how arrays work, and this is actually like arrays are actually quite awesome, and the reason that arrays have some of you asked this a while back, right? Like arrays have order, hashes don't have order. Like why can't we have hashes have order? I think Dom, you asked this like ages back, right? Like, why does like sorting a hash return an array, right? Why can't it return a hash? Well, hashes have no order. In fact, like the way that hashes are implemented under the hood make it like very difficult for them to have order. It is like technically possible, but extremely difficult. It's not quite like their primary functionality, but like for arrays, it is critical that arrays have order, and it's actually what gives them extremely good lookup time, right? So if we do like nums like 2, we get 6. And the computer doesn't have to like search through every single element in nums to find that like 6, right? It can do this extraordinarily quickly by using pointer arithmetic. And basically how that works is an array is always consecutively stored in memory, right? So if you think of memory as like all these little boxes, right? When you start an array, you have like this first element, right? And then like the computer holds a pointer to that first element in memory, right? And so it's like, all right, I know that like this array, object ID, whatever, like 2840, right? Like nums that has like arbitrarily long numbers of elements. What I'm going to do is I'm just going to like store a pointer to that first element in memory and wherever that starts. And then I know that at a fixed amount of like spaces after that first element, there's going to be the second element that's stored there. And then after that, there's going to be the third element. And let's say that there's just like 4 addresses of difference between them, right? And so like let's just say nums 0, right? That's 4. That is like stored at let's just say that this is stored at, let's say, like a memory address like 1000, right? Just totally arbitrarily. And then so if that's memory address 1000, this we will know guaranteed is going to be at, let's say, like memory address 1004, right? And then nums 2 is always going to be guaranteed to be at memory address 1008 and so forth, right? And so basically that's like that's really powerful. I'll just write up here. Nums equals 456. That's extremely powerful because what that means is that you can actually just key into this at any point and you can just immediately know that using pointer arithmetic where you should look in memory to find the next element, and you can do that for arbitrarily long numbers of elements, right? So like it's trivial to do nums like 1000, right? Nums 1000, what you would do is you would just do like 1000 times 4, right? And so that's like what, 4000, and so this would just be like 4000, right? And hopefully I'm not off by 1. It's either 4000 or like really close to it. But anyway, yeah, long story short, like this is like really trivial, right? Whereas if you actually like if they weren't stored consecutively in memory and you just had to like somehow like search for them, then like this would take a huge amount of time. Thankfully, our computers are really fast, so it actually doesn't take that much time. But like it would under the hood be literally your computer like searching. Okay, let's see. Like I'll go to like 0. I'll see what that is. I'll go to like 1. I'll see what that is. 2 and so forth and whatever. Right, and then I'll like go through the whole thing and then like have to get to here. But because it knows exactly like where this is. And there are other structures like a linked list, which actually you do have to like trawl every single other element to get to 1000. But for an array, because they're all stored at the same place in memory, you can actually just like directly just key into that immediately in like no time at all, and then like get the value that is stored at that point in the element, right? And then anyway, so yeah, let's do something like this, which we've already done. So again, this should be a review for y'all, but pay attention. Let's say we change other nums to 20. Okay, does anyone want to tell me? Okay, so other nums now looks like this, right? What does nums of 1 point to? Dalibor. Dalibor.
Hello?
So,
let me see, what was it before?
before it was 4, 5, 6, right? So before it would be what, 5, right? So what do you think it is? Is it still 5? Is it something else?
Yeah,
What's that?
I think it is 5.
You think it's still 5?
Mm-hmm.
Cool. Does everyone else agree? Anyone disagree? Dom, what do you think?
No. Since we changed the thing that both of them point to.
Okay, so can you explain that a little bit more? Okay, so we changed this. Why might it change this as well?
Oh, okay. So since nums is unique to a section, which is pointing to an array, which is like 4, 5, 6, and we change, and other nums are pointing to nums, which is the same section. So if we mutate the array, both nums and others nums will change.
Perfect.
Since they both. Yeah, I don't know if does that make sense. I mean, is that?
Yeah. No, you're totally right. Yeah, they point to the same array in memory, right? And so if you change one of the elements in that array to point to something else, then the other one's also gonna point to something else, right? And in fact, there are multiple ways to answer this question. In fact, the answer was literally just written on that page, right? If you look at nums 1 at the bottom, it says it's 20, right? It's not a trick question. You can just read it and you'll find the answer. Good job. That's basically it. Does that make sense to everyone? Does anyone have any questions? If not, we're gonna move on. But yes, you're exactly right. That was good. Cool shit. Okay, so now we're gonna talk about the difference between concat, shovel, and plus equals. Now this is gonna be very, very important for you all, especially when you're going to recursion. It already was important for things like my flatten and like all those things, right? And it's extremely important because you need to know it. Okay, does anyone want to explain to me why, how these things are different? Dom, do you have any idea? What's the difference between concat and plus equals?
Sure. So, I'm not sure. I'm not super familiar with concat, but I can explain the difference between plus equals and shovel.
Cool, man. Yeah, go for it.
So plus equals is if it's syntactic sugar for like something equals something plus something else. Writing all of that, you can just write plus equals. So we're still using the equal sign, which is which makes variable reassigned to a new like section, like change the pointer to like a different location, and the shovel actually mutates the. So let's say it doesn't change. It doesn't change the pointer. If that was the question.
Yes, that is extremely good. Very, very impressive. That's exactly right. Yeah, so let's say we have two arrays, right? Array 1 and array 2, and we do r plus equals r2. How would you rewrite this Jeffrey to say exactly what Dom was saying. Like, what is this syntactic trigger for? Jeffrey? Jeffrey? Are you still in the bathroom? Oh, fuck it. Maybe? You want to rewrite
I
this?
forgot to unmute myself.
Okay,
I'm
cool.
so sorry.
Awesome.
So yeah, plus equals is just equal to array plus array 2 in this instant. Yeah.
Nope, that's incorrect. Mady, do you want to slightly clarify that?
So plus equals in this sense, wouldn't it make another array that's 1, 2, 3, 4, 5, 6? So
yeah.
it joins array 2 to array 1.
But can you? Okay, so this is syntactic sugar, like Dom explained, right? Can you just write this so it's the long way of writing it? That's not with the syntactic sugar. Like, what is this? Literally?
Oh, yeah. So array equals array 1 plus array 2.
Yeah, exactly right. That's exactly it. Yeah. So, like Dom said, this is exactly this. And now we can see this more clearly. There's an assignment here, right? So you're exactly right. This creates a new array. Okay, so let's look into that a little bit more, right? Let's go here. Let's make an array. Let's do what, like r equals 1, 2, 3. R2 equals 4, 5, 6. Okay, r.object.id, and then let's do a r3 equals r. Let's just play around with that. And r.object.id is this. r2.object.id is, of course, something different. And then r3.object.id. Does anyone want to tell me what this is? Is this, what is this? Does anyone know? Anthony, what's the object ID here? Do you know?
Yeah, I do. It'd be the same as just regular R.
Perfect. Good job. Yep. It's just the same as the array's object ID. Good. Okay, good. Okay, so now, at this point, if we do r plus equals r2, Dalibor, do you want to tell me what we get?
A new object ID.
Yes, and what is it going to equal, that object? Good answer, by the way.
I'm not sure. What's the question again?
Like, what? Okay, so what variable will that new object ID be assigned to, and what is it going to equal? Like, what's the value of that object in memory?
So you're gonna definitely give us. I'm hearing double myself.
Yep.
So it's gonna give us a new object ID with all the elements of both arrays.
Yeah, that's basically correct. I would say it's not a it gives us a new object ID for sure, but that new object ID points to a place in memory, right? An object in memory that is this, right? And so now if we do object ID equals our Dom, is this true or false?
It's loading.
Yeah, we have like a 5. It's not more than 5 seconds delay.
Damn. It should be up now. I'm checking my own thing too. Yeah. Is this true or
No,
false?
it's all good. There would be a difference since we reassigned the R.
It would be what now? Sorry, one more time.
Since we reassigned the R, then it will be equal.
Wait, is it true or false? Sorry, you're cutting out a little bit. False. Okay, good. Awesome. Sorry, man. Thanks. Perfect. Yeah, you're exactly right. We reassigned it.
Yeah.
Perfect. Yeah, you totally understand. Okay, good stuff. Good. Awesome. So now, why don't we try something else? Why don't we go out and we'll just clear that whole thing and we'll just do the whole thing again. And this time we're gonna do something slightly different. Why don't we do this? Why don't we do r2 equals 4, 5, 6? Why don't we just do r3 equals r? And then why don't we do this? Concat R2. Does anyone know what concat is? Has anyone seen this before?
Yes.
Okay, good. Dom, you want to explain to me what this does?
I'm not sure how it works with object IDs, but essentially we'll just put the array 2 into array 1. So it's going to be 1, 2, 3, 4, 5, 6.
So what will be 1, 2, 3, 4, 5, 6? R2 or R1?
R.
R. Okay, good. Okay, good. Yeah, perfect. Good. Okay. So now how about this? Does R equal R3? Anthony, do you think that r.objectID equals r3.objectID?
I don't think so. Because one of them is R is just going to be the same as the original R, and then when you reassign the R is equal to like R1 plus R plus R2, then it's going to create a new object ID for that. So I think they're going to be different.
Sadly, you fucked up.
So,
But yeah,
I mean, as in, like,
they are the same. Exactly right. Yeah, so that is a key difference between plus equals and concat, okay? Concat is mutative, and plus equals is reassignment, right? And so basically that is the problem, is they look exactly the same on the face value, right? But in fact, they did something quite different, where R plus equals R2, right? Also gives you that same thing, but you have to be aware, under the hood, it's R equals R plus R2, right? And so this is a reassignment right there, right? When you do that, you reassign R to R plus R2, which means that this now points to a completely new object ID. However, if you just call this method on R, in fact, yeah, the method cannot reassign self. I don't think that's possible for it to reassign self. I need to look into that, but yeah, I don't think there's any way that you could actually call this method and it would like change the object ID of the array. It might be possible. No, you can't. Yeah, I don't think you can do like a self equals something else. Maybe. Anyway, long story short, yeah, like this just mutates the R. So basically, anything that points to that same object in memory, that object ID is the same as it used to be before. Let me show that one more time. Like just before, let's do R equals 1, 2, 3, and then we'll do r.objectID, and then we'll do r.concat r. Why don't we just eat itself, right? And then we'll see that that object ID is still the same, right? And then in fact, if we just do something else, why don't we do like r2 equals 4, 5, 6, and why don't we eat that one too? Why don't we do concat r2? Hey, does anyone want to tell me what this is? How about you, Dalibor? What is this going to equal? What array are we going to get back?
1, 2, 3, 1, 2, 3, 4, 5, 6.
Yep, that's good. You stole Dalibor's thunder. Good job, Dalibor. Were you going to get that right?
I'm listening to you on YouTube, so I do have like 5 seconds delay.
Yeah, I know. But were you going to get that right? The answer.
Yes, of course. Okay. Absolutely.
Great.
What did you think?
Yeah, of course. Good job. Yeah. Anyway, that's exactly, yeah. All right. So is this object ID going to be the same as before, Jeffrey? What is this object ID going to be? You're muted.
That'll be a new object ID.
False. Totally fucking wrong. None of you get this stuff.
Same.
Yeah. Oh god. Shit. Like what? Why did you think it was gonna be a new object ID?
Because it adds like extra stuff to it.
Yeah, but it's mutation, right? It's not assignment.
Yeah, it's mutation.
It is mutation. So
now, plus equals, it would be a new object ID. When it's concat, it just does one.
Exactly. That is exactly the point we're getting to here.
So I was wondering, do you know like how long an array has to be for it? So if it's always sequential in memory, right? And the array is dynamically allocated, like what's the initial value that it dynamically, or technically couldn't you go like an infinite amount after the array's memory? Or is there a limit?
Yeah, that's a good question. I don't know that there is any limit in like Ruby. Like certainly there is some limit to any kind of code that you're gonna run, right? Your computer is gonna run out of space at any point. Let's see, maximum length of array in Ruby. Yeah, I don't know that there is, let's see. Yeah, there is not a software limit imposed by Ruby, but there is a limit to, let's see, array size too big Ruby. So
there would probably be like a hardware limit mentioned.
Yeah, there's not a software limit, but there is a limit to how much the process can support. If you have a regular home server running the Ruby server, it would be able to handle an array until the array became too large, and then it would crash. Yeah, so basically, like, you will know that it's too large when your computer crashes. Let's see. I'm getting an argument error, array size too big message with the following code. Max number 600 million, array.new 600 million. Let's see. Yeah. And the answer is array with 500 million elements is 2 gigabytes in size, which, depending on the specific OS you're using, is typically the maximum that process can address. In other words, your array is bigger than your address space. Yeah, so basically, your array can be as large as all the address space that is allocated for your process, which is a large number. You will never need to have 500 million elements in an array. If you're doing that, you're doing something wrong. So please don't do that. But cool, awesome. That's in fact, like there's a good problem that I think was in the test generator that you may have all solved. If not, it's probably a recursive problem. But like there is a point at which you will have to like do an iteration of like 0 to like 100 million or something, right, or something like that, or like.
I was like going through my stuff.
Sorry, what's that? What'd you say?
Your audio is coming out.
Oh god damn it! I ran out of memory. Yeah, thank you. Let me see why that is. I have really good fiber. God damn it. Yeah, it is stumbling. Let me see.
Now it's good. Now I can.
Okay, now you can hear me again. Yeah, weird. I might have been changing mesh networks on mesh, like routers. That's weird. Anyway, okay, cool. So as long as you can hear me, that's good. Cool. All right. Let me know if that happens again. Thank you. Cool. Yeah. So basically, long story short, that is the difference between those two. Good question. Yeah. It turns out like Ruby will just dynamically allow you to continue like adding things to an array over time and like move other shit around, right? Such that you can in fact have this like huge ass array, but like try not to. That's really bad. It's really like process intensive and so forth. But anyway, cool. So now with the shovel, that's the last little thing here, right? And so let's see. Can anyone tell me what this is going to give us? What is array shovel array 2 going to give us? Dom.
I mean the idea of
What'd you say?
like it won't change the array. It will be the same ID as before.
No, but like what? More specifically, like wait, why do you think first it won't change the array?
So we're shoveling. We're mutating the array.
Okay.
An array 2 to it. So we're not reassigning. Like we're not changing a pointer.
We're not reassigning. That's for sure. But I'm just curious. Like, what are we gonna get as output if we try this?
The output. Okay, what's array right now? So array is this. Now what's R2? So it's going to be 1 2 3 1 2 3 4 5 6 4 5 6.
Nope, incorrect.
With this.
Maybe you want to give it a shot.
That's just going to put. It's going to make a 2D array.
Nope. Yes. Oh. You're exactly right. Yeah, good call. Yeah. Perfect. Yeah, good. Yeah, Matey was exactly right. That is exactly what it does, right?
You're like, Matey, you're exactly wrong. Wait, Matey, you're right.
You're right.
Change.
You're totally right. Yeah. I thought you meant something slightly different, but you're totally right. It is a 2D array. It shovels in that last element as an array in here, right? So what this does is it shovels in a basically just whatever you pass it as one single element, right, in the array. It just like it's the same as like pop, right, or push rather, right? Like what is this going to give us now? Anthony.
Push is going to be the same as shovel. It's going to mutate the original array and do the same thing as shovel.
Perfect. Yeah, I'm actually kind of curious. Whoa, that's trippy shit, man. So I've never tried this before, but I just pushed the array into the array, and it now has a reference to itself as its last element. And so I guess we could just keep doing this, and it would probably just like keep giving us the same thing. Yeah. So
are you going to overload it?
What's up? What'd you say?
So wait, what's the array at that element then?
It's the array. It's the same thing. It's the array itself. Yo, if we do this, what do you think is going to happen? What's going to happen here? Does anyone know what's going to happen if we do this?
Like infinite array.
Nope, nope. This is going to do something. Lorraine, do you have any idea?
What's the... Alright, so array object, you called that, and where you're trying to call now?
Oh, I'm doing array last element, the last element of the array, and then the last element of that array, and then the last element of that array, and then the first element of that array. I'm setting that equal to hello. What do you think that code will do? Anyone?
Hello, 2, 3, 1, 3, 4, 5, 6.
Yes. Let's see if that's correct. And it is. Good job. Yeah, perfect. Isn't that trippy? That's like some super trippy shit.
Yeah.
But yeah. It turns out Ruby is like very flexible in that you can actually store a reference to the array inside itself, and then you can key into that, and it'll give you that exact same array back, which is itself. And then you could key into that again, and then you could key into it again, infinite many times, and then you could change an element in there, and then it'll change an element in that array itself. So that's like super trippy acid shit. But anyway, that's not important. You should never be doing that in your code. I'm not sure why you would ever do that, but you can if you need to. Cool. All right, so let's move on. Let's go to array and hash defaults. Everyone feel somewhat good about this? You did have like a correct answer rate of like 30%, so I am kind of concerned about all of you. But hopefully that does all make sense. Like, does anything not make sense at all? Feel free to shout out if it doesn't. But anyway, okay, cool. So let's talk a little bit about array and hash defaults. And so these are ways that you can like make arrays, right? Like by now, all of you should absolutely know this. This should not be difficult. You can do r equals this, or you can do r equals array.new. They both make new array. You can do the same thing with hash equals hash object curly brackets, or you can do like hash.new. That's cool. And yeah, syntactic sugar, like before, right? Like we've talked about this, right? These are all just like oh yeah, I mean this one's kind of important for you all to know. Do you all know what this does? Let's see. Let me start over here. Let's do system clear, and then let's do this like so. Let's do r equals 1, 2, 3, and then let's do r2 equals nil, and then we'll do r3.
I have a question.
Yeah, go ahead.
What is I saw you type system clear. What does that exactly do? What's different from that than clearing your terminal window?
Oh, well, that's a good question. The thing is, I can't do clear here, right? There's no method or variable called clear for main object. I'm inside a pry program now, right? I'm inside the pry program, which is, it runs Ruby code, right? And so I can't make bash calls inside here. Here I can do clear, right? When I'm in the bash, I can just write clear because that's a bash command, right? And that literally just clears the terminal, right? You can scroll up, you can still see it. It just like adds more white space at the bottom. That's it. It's kind of tacky. But anyway, like inside pry, I can't do clear, right? Because now I'm inside Ruby, and there's no method Ruby called clear, no Ruby method called clear that I can like call in here, right? And I could define one actually. You know, I could do def clear, and then this would just do what, system clear, and then end, and then now I can do clear. Ta-da! Clear. Awesome, great. So I could do that, but like, does that kind of make sense? System is a
That makes sense.
yeah. System is a like a method in Ruby, right? And system just like lets you do system things. So wow, that's cool. That's weird. I wonder what that did. Hello. Okay, yeah, that's weird. Yeah, that's cool. Anyway, yeah, you can put whatever the fuck you want to system. Who knows what the fuck system does? Anyway, hopefully that makes sense. All right, cool. So yeah, let's go back to what we were doing before. So I'm gonna reset my pry. That's the same thing as like quitting it and like starting again. All right. So let's say we have array 1, 2, 3, and then we have array 2 is nil, and then we have array 3 plus equal. This is r. What is this going to give us, Dalbor?
Array 1, 2, 3.
Yeah, great, awesome. Can you explain why?
One of those special cases, right?
Nope.
So this assignment will happen only if how to explain it? Shit. It's either 1 to 3 or nil. If nil doesn't have any value, it's going to be 1 to 3.
Yeah, exactly right. So, good call. Jeffrey, do you want to tell me what this does now? Or actually, maybe better for you to do it. R3 pipe equal R4.
That's going to wait. Wouldn't it just be array 3?
What do you mean? Like, what is it going to return? What is array 3 going to equal?
4, 5. Wait. I'm confused.
What are you confused about?
The default argument for array 3 isn't defined?
What do you mean by default argument? What are you talking about?
So since there's no array 3, would it just be 4, 5, 6?
Is there no array 3?
Oh, should it be just 1, 2, 3?
Why? Why would you say so?
Because in the where it goes array 3 or array equals array, and it's 1, 2, 3.
Exactly right. Yep.
Is what the result.
Exactly right. So this, you can see this is syntactic sugar, right? There's an assignment here, right? So there's an assignment. Does anyone want to tell me what the syntactic sugar simplifies to, Jeffrey?
It's basically if array 3 exists, return array 3 or return array 4.
Yeah, but can you actually write out the exact code that it simplifies to?
So if
no,
array
no, it's not an if. Nope, not an if.
Oh.
Dom, do you know?
No, I don't know.
Array 3 pipes and then array 3 equals to array.
Wait. Array 3 pipe and then array 3 equal to array like that? Is that what you're saying?
Seeing if it loads. I mean,
now, does that logically make sense to you? Does that seem right? Have you ever seen any code that looks like that? Now, let's think about something else. Why don't we use some logic here, and then let's say, do you all remember what this was like? What does this do? Do you all remember this? How do we rewrite this?
Q Q Q Q Q Q Q P P P P P P P.
What the fuck?
Said you were right.
What the hell is that? That was amazing.
Speech chat, I'm sorry.
Okay.
Can I just pause the speech chat? Okay. Yep. We can move on. Yes. Okay. So where are we? Like, what are we doing now?
Do you see on the screen? Like this R3 plus equals R. How do you simplify that into not the syntactic sugar, but the literal of like what it's doing? How do you like make it the longhand way of writing it? What's this equal to? R3 plus equals R.
Okay. Oh, wait.
One step at a time. Tell me what this
Okay,
is.
so would it be, would it be like equals array 3 plus R?
Yes,
Would it be just equals and then array 3 or array 4? And since
so
it's
now,
then
yeah. So can you now apply that logic and tell me what this might equal? The R3 pipe equals R. Anthony.
Would just be array 3 pipe ARR 3 plus AARR.
No. Let's apply that logic again. Let's take a quick, close look, everyone. Okay. let's use a very, very close eye and let's look at this. This equals this, right? What might this equal? Dalibor, you want to give it a shot?
Hold on, you're still typing here. Okay. R3 equals R or R.
Good shit. That was really, really close, but you got the right idea. Exactly right. Yes. Good job, Dalibor. You got it right. Everyone else, you got it wrong.
It could be the other way around. So it could be R and then or R.
Well, actually, no, it can't. In this case, it specifically cannot be the other way around. Can anyone tell me why it can't be this other way around? Why it cannot be like this?
Because if the first one is true, then it will return the first one, right?
Exactly.
So whatever is true. Okay.
Exactly right. And this is in fact how it works, right? And so like if you had this around, then this code, this shorthand would not work because it would always set R equal to R if R was defined, right? So basically, can anyone explain to me why this works, right? Why it just stops at the first thing that is, how does the OR sign actually work? This was in Foundations. Matey, do you know?
What, the syntactic sugar for or equals?
No, not or equals, just or. Do you know what this, like, how this works? Like, what is the difference between lines 32 and 33?
I mean, one is R3 pipes equal R, and the other is R pipes equal R3.
That is the literal difference.
So one is saying...
Yeah, exactly, yeah. Go ahead.
So one is saying, hey, the default value is R3, and the other's default value is R.
Nope,
for R3.
That's not what a pipe is. That there are no things like default values in pipes. Let's see, Jeffrey, do you have an idea?
Yeah, so pretty much the way I understand it is that the OR function basically checks the first value, and if that's false, it'll check the second value, but if the first value is true, it won't ever do what the second value was. So that's why you have to do it in that order, because it does them sequentially. At least visually sequentially.
Okay, so I'm going to write this code. Do you all see this down here? Val equals nil, or false, or hello, or we, or true, or false, or nil, or goodbye. Can anyone tell me what this is going to equal? What is val going to equal?
Hello?
What's up? Yeah, perfect. Good call. Yeah, it equals hello. Can you explain why?
Because the only sort of, well, nil is and false is false.
Exactly.
So the first true value is hello.
Exactly, yeah. So this OR operator is a lazy evaluator, right? It lazily evaluates. And so how that works is it only evaluates up to the point where it hits like that first thing that is true, a truthy value, and then it stops evaluating everything else afterwards. Yeah, so what are the only falsy values in Ruby? Anthony?
Nil and false.
Yes, exactly. Everything else is what?
True.
Exactly. It's truthy. Yeah, exactly right. Yep. And so basically, how this syntactic sugar works is it works by this. It basically, like, this whole idea of a default value thing is like a false. It's a red herring, right? It basically says, if you don't define a variable, right? If we do like R6 or something like that, it's undefined. But if you write it in here, like, it's gonna be it's gonna be nil basically, right? It's gonna evaluate to nil. So if you do this equals R6 or R3 or something like that, right? If you just write this, then like what this is actually doing is, and you can see, like, of course it has to be the assignment first, right? It's exactly the same as the syntactic sugar with the plus equals, right? That's what I was trying to get to here, right? Like, what you're saying is let R6 equal the first non-falsy value, right? If R6 is already defined, then it's the first non-falsy value, right? Because it has a value. If it's not defined, it's a falsy value, right? Therefore, this thing keeps evaluating until it finds the first non-falsy value. And like if you wrote it this way, presumably you would want R3 to be this like catch safe that is in fact a non-falsy value, right? Something that does have a value attached. And so when it hits this, it'll be like, that's my first non-falsy value. Great. Let's go forth and like use that. And then it would just set that equal to this, right? So this sets R6 equal to the first non-falsy value. If it is itself undefined, then it would be a falsy value, and therefore R6 would be set equal to whatever R3 points to. Make sense? Good? Awesome, good. All right, let's talk about that last one real quick. And all right, let's talk about this this last syntactic trigger. Does anyone want to guess how this one works, y'all? Let's see, this right here. 4. Okay, so I'm gonna go ahead. I'm gonna go into pry. I'm gonna make a new array. I'm gonna do this array equals 1, 2, 3, and then. All right, Jeffrey, you want to do it? You want to give me a shot? What does this do?
Array. The array 3, 0 equals 3. Array 0 equals 5. So that reassigns the first value of the array equal to 5.
All right, cool, awesome, great. Let's do that real quick. 0 equals 5, and let's take a look. You're right. Okay, what does R2 0 equal?
R2 0 equal. R2. It also equals 5.
Good shit. You guys are getting it.
Yeah.
Yay. Does that make sense, everyone? That's a pretty short, straightforward, like syntactic trigger. Cool. Cool. Good stuff. All right, we're gonna move on. Good stuff. All right. Okay, so now what we're gonna do is we're gonna talk about making a 2D array. Okay. Now, can anyone explain to me what this first one would give us? Y'all ready? Dumb. Let's go for it.
So it will set the. It will make every single array point to the same array, to the same subarray.
Yeah, but what are we gonna see? Like, what exactly is it going to create?
There's going to be like a 2D array where with 3 subarrays.
Yes, exactly right. Yep, perfect. 3 empty subarrays, exactly right. And yeah. So you already know this. That's good. Let's see. Matey, can you tell me why this is bad?
Because all the elements are the same array.
Exactly right. So if we do this, Jeffrey, can you tell me what we're going to see if we type array?
We're going to get 3 hellos.
That's
Oh, yeah. The full thing, yeah.
Oh yeah. My bad. I screwed that one up. That was my fault. All right, cool. Let me redo that one again. One sec. I did not actually shovel into it correctly. All right. So if we do this, in fact, is what I meant to do, and then if we do this, what are we gonna get? We're gonna get 3 hellos, exactly like you said, right? And so basically, yeah. So this one, I was accidentally, I like thought that I was actually keying into this first one, but I was not. I was reassigning that first element to just a string hello, and so I reassigned it over these 2, right? And so it did not actually change those, of course. But and when I shoveled into that array, that is R0, then it shoveled into all of them, right? So that's usually not the behavior that you want, right? Normally, what the behavior you want is something like this. Can anyone tell me what this this kind of second line of code with this block does instead? Anthony, what are we gonna see?
Shouldn't you put array.new in that block, or do you want?
Well, they're the same. Remember, like.
Okay, then you're going to get 3 subarrays, but they're not going to be interconnected with each other. You will be able to change one of them without mutating the other 2.
Perfect, perfect, really good. Does anyone know why that is? Why is this block of code different from the this like parentheses thing?
The first one makes just like the elements are a shallow copy of that one. The second one makes a deep copy. Well, no. The element makes like 3 separate elements.
That's close. More technically, specifically with Ruby, like what happens is the first one. If you so you might not know this just because like you haven't worked with Ruby that much, but basically there are 2 ways that you can pass in a block to array.new, and like blocks are very interesting compared to this, right? So when we did like array.new with 3 and then this is the syntax to instantiate a new object of the array class, right? So imagine that class array is like this, right? We have a definitionalized method in here, right? And this takes in 2 arguments, right? It takes in length, and then this is just equal to normally like a 0, right? And then let's say it takes in default equals normally nothing, right? So let's say this is just a optional argument. Default is 0, whatever. We'll just put that in there. Cool. So basically this is how it works, but this can also take a proc. And so there's a yield. You may not have seen yield yet, but anyway, so basically what this does is this syntax fundamentally can only take in 1 argument, right? You cannot pass in 3 different arrays into this this like instantiation method, right? You can pass in anything that you want here, right? It could be hello, right? But that hello is going to be all of the same. It's going to be the exact same object, hello, right? You cannot like pass in 3 different things in there because you just can't pass in different things to like an argument, right? Like you're literally this syntax says that you're passing this in as an argument to this method call that you're making, right? The .new method call. You're passing in 2 arguments. The first argument is defining the length of the array, and then the second argument is defining whatever you want the default value of each array to be set to, right? But you can see these object IDs are all the same, and there's no way that you could really change this, right? Because like, how could you pass in 3 different things here, right? Like that just doesn't work. It just like there's no way for the code to like allow for that. So you see, like, it only expects up to 2 arguments, right? You cannot pass in more arguments into the array. And so there's a way around that, though, and that's a code block. And so what a code block does is quite interesting. What the code block does when you pass it in like this is Ruby's like kind of like cool, hacky way around this, is that code blocks are optional here, right? In fact, every single method can take a code block. Even if you don't specify that it should take a code block, it can. And so we can do a random method, and we'll do something like this, right? And then what we're going to do is we're going to call this, let's say, yield. And this is going to take in an argument, let's say name, right? And then we're going to do yield, name, like so. And then let's go ahead and let's do something like we'll do random method, and then we're gonna go call this with a block here, and we're gonna do name, and we'll just call this n right there, and then we'll do puts hi n, okay, and then we're going to go and we're going to run this method now, and then we're going to do n puts n, yeah, hello. Let's call this Dom. Did someone have a question? Yeah, actually I'm not sure if this, this might give us an error actually. Oh no, it doesn't give us an error. Okay, cool, so you can do it like that. But can you all see what happened here? So basically, when I ran this code, it basically I used this yield. You may have never seen yield before. You're not usually supposed to use yield for you're supposed to be a little bit more explicit about your procs. But anyway, basically what happened is this method strangely does not take in a block like explicitly, right? But yet we did pass it a block, right? We passed it this block of code, and yet it just took the block of code. It was like, all right, that's cool. Like, give me a block of code. Who cares? Every single method in Ruby takes a block of code implicitly. you don't have to like specify that whatsoever. It'll just do it. And so it took that block of code. And can anyone explain what it did with that block of code? Dom, it's your name, so how about you do it?
Wait 1 sec. Well, it said to so is the n the thing that we passed in, and then just that's what I would compare it to be.
Exactly. What's another way that we can write this? Does anyone know the way that you were taught to write this? That you should know how to write this? Indelible.
Return.
Oh, yeah. I mean that returns are actually implicit in Ruby, which is quite interesting. So this, yeah, you're right. Like return is necessary, but there's actually a different way to do this, and it's with something with an ampersand. Does anyone remember anything with an ampersand?
Yeah, the proc.
Cool, awesome. You want to write this? You want to write this differently, the way that you were taught, Dom?
So it would be comma ampersand proc.
Okay, cool.
Sure.
Yeah, in fact, this can be anything. This you can put anything in there. It's just a variable. Okay, and then what do we replace the yield name with?
It would be proc person.call.
In fact, it's actually anything.call in this case, right?
Yeah, I'm sorry.
Exactly.
I didn't see that you were saying. Yeah.
Exactly right. Exactly.
So, yeah.
Yeah, perfect. And we can see again, it works just fine, right? And there's a slight difference here, though. Let's say, like so. Let's call this one Delaware. And oh shit, we got an error. Undefined method call for nil class, right? And so that's the error that we get here if we do this, is that it expects us to have this like anything there, right? Because we like specified that we were gonna get that, and then when we like try to use it, right, then we get an error. Though if we don't try to use it, if we just do this though, it's chill, it's cool. So it's okay to like have this in here. It won't break anything, but like if you do this call here, it's gonna break something. But you know, it would do that with yield too, to be honest with you. But anyway, long story short, like just no block given, right? You get that error, no block given. Whenever you use a yield, it has to be used on the block. But basically, this syntax, anything.call, is just the more explicit way of doing. What did we get a ping somewhere? Did someone say something? Anyway, okay, whatever. Yeah. So basically, these are interchangeable, right? But that's basically what that is what the code for this array class and the hashes and all that are doing under the hood. In fact, what they're doing to make this safe is they're going to do this, right? If anything.call, right? And this way, your code doesn't break if we do this like random method without the Dalibor, right? But it does accept one, right? And so it says if anything does exist, then do anything.call, right? If it doesn't exist, then don't, right? Dalibor, let's see. Hi, I am a noob. Something.new, something else. Yeah. Yeah, that's good. Good job. Great. I'm not sure why you did. Oh yeah, you put it in a class for some reason. I'm not sure why you did that, but yeah, that's a good job. Good, cool, awesome. Yeah, you get the idea. Cool. Yeah. So basically here, this is what like the array class is doing under the hood in its initialize method, right? This takes an optional block, and it checks if that block exists. Okay, so it does something like this, right? Proc, right, and it says fprc, then do then for each of this for length fprc, then we're gonna do like length dot times like let's imagine that like obviously you can't do this because your array is making the array, but let's say that like it wasn't, and you would just do this length dot times do I, and then in here it would do r shovel prc dot call I, right? And so that's how it's working, right? And so if it doesn't else like else it would just do like length dot times do I r shovel default, right? Hopefully this kind of makes sense to you all, right? This is obviously not how the actual code is written. We can't obviously like make a array inside the array thing, right? Like that would not work, right? Because this itself would also call the array.new, right? This would be an infinite recursive loop, right? And it would just break. But let's imagine that, like, you know, this is how it's making the array under the hood, which it's not, again. Like, this is how it would instantiate it, right? It would say, okay, how long do they want us to make this, like, length? And for that many times, let's shovel into the array that we're making whatever the result of calling this block is, right? And if they don't have that, then let's, like, shovel into the array whatever this default is, right? And then you can see this default is just one object, right? Literally one object that we passed in, cannot change, must all have the same object ID, right? And just like, it cannot be anything different. Oh crap, my bad. I forgot that you guys can't read code that goes off my screen here. So let me make this shorter for y'all. Let me see that you can all see that. 1 second real quick. Yeah, let me know if my code gets cut off at any point. Or yeah, you can see my comments get cut off. Okay, that's rough.
You can press Alt-Z.
Sorry, what'd you say?
You can press Alt.
I can press what?
1 second.
Alt-Z. Okay, let's try that.
He's talking about Control-Z.
Uh,
Oh, I know what he's talking about. Word wrap. Word wrap. If you go up to the top, Alt-View, down to word wrap.
Yeah. Awesome. Thanks, man. Yeah. Oh, I see what you're saying. Yeah, exactly. Yeah. Wow. For some reason that didn't do anything for me. That's kind of depressing. Anyway, fuck it. Whatever. Oh yeah. Whatever. Like, I'm just going to make my code like less over that line break thing. Okay, cool. So is just one object, literally one object that we passed in, must all have the same object ID is what I'm trying to say. But yeah, so does that code make sense, everyone? Let me know if it doesn't make sense. But that's like, what's up? Go ahead.
Could you go ahead and please select all and copy paste it into our chat?
Because you can't read it, or what's going on?
Yeah, mainly.
Do you have the stream on 7020 HD? Or what is your encoding right now?
Yeah, it is. And somehow it's just, I'm not seeing it entirely.
Wait, what are you not seeing entirely? You can read it, but you can't see it entirely, is what you're saying?
Correct.
What are you missing? Let me check real quick. Let me go on my screen. Does everyone else see everything? Like, can you read that line 51 to me? What do you see there?
Literally one object that we passed in.
Yeah, that's it. Yeah, it stops there. Yeah, there's nothing past that. Yeah, so you're good. Yeah, I just started writing on the second line. So you should be able to see it all. At Dalibor, you see that, right? It stops at past, right? That's the last word that you see.
Okay, yeah.
Yeah, okay, cool, awesome. Yeah, my bad. I just totally forgot about that. Yeah, interrupt me if I, like, forget about this. It's just that the stream has limited space, right? And so, like, my monitor goes on and, like, my Visual Studio Code goes on, but I'm going to stop at that line break from now on. And if I don't, then remind me. So if you see, like, this going on over there, then you'll see, like, yeah, there's more code, and so you should say, hey, Ben, don't do that. All right, cool, awesome. Anyway, so moving on. Basically, this is how this, this, like, works under the hood. And so now we can think, okay, so how does this magically now give us multiple new objects? Well, a block of code is something that's called multiple times, right? And so every time this is called, it's actually running that code again and again and again. And remember, this is just a, remember when we do this in our thing, right? When we do, because they are mutable things, if we do R is this, right? And then we do R2 is this, right? Can anyone tell me, like, do those object IDs equal the same thing? Or are they different object IDs, Anthony? Let's see, if you look at that, well, fuck it, I just did it. Anyway, okay, the answer is false. They are not the same, right? So basically, like, yeah, every time you run this block of code again, this will run the block of code multiple times for the length, right? Oh, god damn it. I went past the line. Okay, for the length, it will just keep running the block of code for each element in the array that it's supposed to make. And when you run a array instantiation in a block of code, it will create a brand new array every single time. Hopefully that makes sense. So yeah, so basically, if we like think a little more critically about this, we'll realize, in fact, there's some really cool stuff you can do here. A block of code takes any kind of arbitrary shit that you're gonna pass it, okay? And so we can do just anything the hell that we want, right? In this block of code, we could do, let's say, puts, hi friends, isn't coding fun? It's so fun. I'm having a great time. Aren't you all having a great time? And then we'll do array.new at the end there, right? All right. Can anyone guess what this is gonna do? How about you, Anthony? Anthony?
I'm actually not sure what it's gonna do.
That's cool. Maybe.
Yeah, I don't.
It's going to have three. It's going to have one array with three arrays with all of that in it. When you hit array, what?
Not quite, but that's a good guess for sure. Jeffrey?
I think it's going to print all the things with puts in front of it 3 times, and then make a new array with three arrays. Not 3 values.
3 values of what?
There's not going to be anything. It's going to return array.new, so it'll just be an array.
So it's going to make a new array with 3 new arrays in them, but it's going to print all that stuff 3 times. Is that what you're saying?
Yeah, pretty much. Because when it runs that code, it's just going to print that stuff to terminal.
Fuck yeah, you're totally right. Good job, dude. You really got it. Yep. Can anyone explain why it just gave us an array back with these 3 elements, even though it printed all that stuff 3 times? Just imagine that this is literally the code that runs. It's not, obviously, again, right? But like, imagine that it is on lines 45 to like 53. Can anyone explain that? How about you, Dom?
Can you just repeat the question?
Yeah. Why did it give us 3 arrays back, and why did it print all this stuff 3 times?
Because we asked. We said that the length.
Well, why did it not save in here like Matey said, right? Like why did it not save all of this shit into each of the elements of the array, right? Why did it not save like, hi friends, isn't coding fun? It's so fun. I'm having a great time.
Oh, is it because what you saved in there was a block of text? Or not a block of text, but a block?
Well, this is a block
I
for
think
sure.
you ever told you it.
Sorry, what's that? One more time?
You just wrote puts, which
Yes.
prints out the text. Leave it.
Yeah. But you know, even if I don't do that, here, let me do that again. Let's do here. Instead of puts, I'm just gonna do. I mean, I could just do text, right? Hello, we, 3, 47, and then yeah. You know what? Why don't I just end there? What is this going to give me? Does anyone know? How about you, Delbor?
You're still typing here.
Great excuse every time. Give you more time to think about it.
Yeah, he's gonna do the same thing. He's gonna print everything 3 times.
And then what are we gonna get as our array back? What's gonna be inside the array?
Hello, we 3 and 47.
Nope, incorrect. Anthony, you want to try?
I don't think anything's going to be inside the array. It'll just be like empty arrays.
Okay, none of you know anything about blocks is what I'm getting here.
47.
I don't think it's
Good.
going to have anything inside those arrays.
You're all wrong except Jeffrey. Jeffrey's the only one who understands blocks of code. Yeah, so it's 47, right? Because, again, the yield value of a block of code, the return value of a block of code is always the last line that you execute, right? And so when you pass an arbitrary block of code, whatever that last line is what it's going to store as its return value, and then it's going to shovel in that return value, right? When you do on line 47 here, right, prc.call, that's going to return whatever the yield value of that block is, right? The yield value of that block is that last line of code, whatever that last line of code evaluates to, right? And in this case, when you write 47, it returns 47, right? That's the last line of code we wrote in this block. Therefore, that's going to be the return value of the prc.call I, right? And so then it shovels that into the array. Does that make sense, everyone? Like, why we got that so far? And so, like, yeah. Jeffrey, you did get that. That is really good. I'm very proud of you. Everyone else, you should definitely review, like, your basic understanding of a block, such that this makes, like, inherent sense to you, right? Like, if you pass a block, the last line of code, you all know this, the last line of code is the return value of that is what that block of code will return, right? And then if you're doing this, it's going to save that into this array, right? Cool. So hopefully that makes a little more sense about like why we got this result here, right? And I'm just trying to make the point that these are completely arbitrary. Blocks of code are completely arbitrary, right? You can put whatever you want in here. It can be anything. You can like just write new you can't write new methods, but like you could call methods, you could do whatever the fuck you want, right? And then like whatever that last line that is going to be evaluated by that block is, whatever that's going to return as its return value, is what your block of code is going to return for that iteration, right? And then that, in this case, is going to be what's stored as that element's value in this array, right? So that's how it's working. That's why this is different every time, because really what it's doing, where we do r equals array.new 3, and then we do, let's do 5, let's change it up, right? And then in here we say array.new. It's really just running this array.new 5 times. And as you can see, if you run array.new every single time, it's going to give you a new object every single time, right? And so that's literally what the code was doing, right? It's running this 5 new times, right? And you can see as we do this 5 new times, we get 5 new objects in memory. And so as we get these 5 new objects in memory, that's what's stored in these in this huge array, right? All those subarrays are now different arrays, right? Whereas if we just did this array.new 5, and then we do array.new in here, well, that is actually just one time that we ran that line of code, right? And then we passed in that value to be all of these, right? Does that make sense, everyone? Does everyone get why fundamentally this gave us 5 new things? It's not like nothing in Ruby is magic, right? Everything like happens for a reason that is extremely logical and is not like some one-off thing, right? It's not that like, oh, this is just the syntax for making a 2D array that like has like different arrays, right? It's something that like they hard coded into like the array thing, right? No, it's not. It's actually just like it's just a byproduct of how like blocks work, right? And how they like handle the block of code in making the array class, right? And you could do the exact same thing in your code when you're making a class and so forth, right? So that's why I want to impart to you is that like this only works because of like the nature of the blocks, right? It's not like some hard coded, oh, if they pass in like a array inside curly braces, let's do this like special new thing, right? It just is exactly the same thing that I would do with any block of code that you're passing. Make sense, everyone? Cool, awesome. So now we're going to talk about hash defaults, and now you're all going to, this is like one step slightly harder, but now if you use your critical thinking about like how that worked last time, you should be able to figure this out too, okay? So can anyone tell me now why it's bad for us to have hash.new with that little like thing in there? Why is this not going to give us what we want it to do? In fact, can someone explain to me what it is actually going to do? How about you, Dalibor? Gotcha, Dalibor. That's you. 5 seconds later, Dalibor's going to start talking. 3, 2, 1. Dalibor. 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 Okay, Dalibor. You should start talking by now. Oh, god damn it. Alright, Dom, you want to explain this one? Why does it do this? Oh, yeah. Lauren, go for it.
Oh, did he start speaking?
Lauren?
Never mind, okay.
Okay. Yep.
So I think it pretty much is the same thing that the previous slide showed about the arrays. Like makes one item and the others are just to be a shallow copy of it. You insert keys, like that's going to make a new, an empty hash table. But like if you insert a key, then if you insert like more than one key, then they're going to be the same thing.
Yeah, that is yeah, we're gonna do something tricky here, but yeah, basically what you're getting at is like pretty correct for sure. It's yeah, you know, like so what's the difference between a hash and an array? Well, what's this is like setting a default value for a hash, right? And the default value for a hash is whatever is going to be returned if a key is not defined inside the hash, right? So for example, if we do hash, I'm just gonna tell you all this because this lecture is gonna run quite long for all of you. So hash 3 equals hello, right? Now if we look into hash, of course, you know, 3 keys into hello is the value. But then if we do hash 3, of course it's gonna give us hello, right? But what if we do hash 4? What is that gonna give us, Anthony?
I think it'll give you nil because you haven't passed in any default argument.
Yeah, we did. Default argument we passed in was an empty array, remember? Like hash.
Okay, then it'll give you an empty array.
Exactly right. Yep. So basically how that works, if you can see here, is if you already have a defined key that was set to an explicit value, then it's going to return that value, right? But if there was no key, it's doing basically this, right? Like it's basically saying hash or equals the default value, right? Does that make sense, everyone? Like that's basically what it's doing, right? It says like return hash 4 if hash 4 is defined. If it's not defined, then return that default value, right? Basically like that. Not quite, but like same kind of concept. Anyway, so yeah, if it's not defined, it's gonna return just like the empty array. Now let's do something interesting here. What if I do this? I'm gonna throw in Dom in here. Dom, do you want to tell me what hash 5 is gonna return? So we can look at this. Okay, that's that now. Dom, what's hash 5 going to be?
Just an empty array.
Wrong! You all don't get this.
Oh, that's right. Oh, that's right, because we made every single one of those, every single point to an array which has
Exactly right, yeah. Can you tell me what this is going to equal? Dalibert disappeared. Okay, cool. Maybe. Is this true or false?
I'm waiting for it to finish loading.
Yeah, sorry. Yeah, YouTube lies about its ultra low latency, real-time interaction, streaming shit. Total bullshit. Is it not done loading yet?
Where? I didn't see hash 6 ever happen though.
Yeah. It didn't happen.
So it'd be false.
False, it is true. Can anyone explain to me why it's true, Jeffrey? Jeffrey, are you in the bathroom again? You've used that excuse so many times, by the way, and like
maybe like explosive diarrhea.
I meant to unmute. I have bad bowels sometimes, but
Yep.
You're changing the array that all of them are pointing to when you put DOM into it. So every time you do a default array, it's just pulling the same default array, so it's going to be true no matter what. If you did hash brackets like 99, it would be true. Like, it's always going to be true.
You are a smart fucker. Yeah, you got it. Yeah, that's good. Yeah, you know stuff. That's good. I'm proud of you. Yeah, basically that's true. Like to Matey, your point about like this was not defined. Yeah, so if it's not defined, what does it return? Well, it returns the default value, right? What's the default value? It's the same array, right? And so both of these are in fact not defined. Hash 5 was never defined either, right? When we called it here, it's not actually defined. If we look at the hash, the only defined value on the hash is actually 3. And so that's also a kind of important thing, right? When we just key into something, that isn't that doesn't exist, it doesn't automatically define it on the hash. It actually just returns the default value because it is not defined on the hash, but it doesn't like set this equal to default value, right? But you know, what if we do that? What if we did set 5 equal to hash 6? What is this gonna equal now? Dumb. Dumb.
Yeah, I'm just waiting for the thing to okay.
What's up? What'd you say?
So also would it be like empty? Oh wait, no, it would be down.
It would be what?
It would be down.
Yeah, it would be in the array DOM. Yes, that's good. Now, if we key into hash, what are we gonna see? What's up?
Yep, just waiting for the thing.
Yep.
Oh, you mean the hash? Okay, so it would be 3 hello and 5 DOM.
Perfect, perfect. Now, what if we do this? What if we shovel in, let's say, Anthony in here as well? Okay. And then now if we key into the hash, we see that. Okay. Now, Anthony, tell me what this is now. What's a hash of 8? This is all logic, right? I've never done this myself before. I'm just doing this with you all for the first time, too. Who knows what it's going to equal? But maybe you do know. Anthony?
It's gonna
Oh my God.
It's gonna equal the same as 5, right?
So what is that?
Anthony.
Holy shit, you're right. How about hello? What's that can equal? Anthony, do you know what this is going to equal?
I'm thinking it's gonna be
It's gonna be dumbass.
Holy shit, you're right. So yeah, can you see what we did there? That's kind of interesting, right? We set hash 5 on line 18 there, right? We set hash 5 equal to hash 6. Well, what was hash 6? Well, hash 6 was actually the default array, right? And so we set hash 5 equal to default array. And it's really saved in here now. But anytime we change hash 5, we change the default array for anything else that's not defined, right? It's all pointing to the same array. Mind blown. Yeah, so like this equals any random thing. It's all the same. It's just this whole, hopefully you all understand the central theme of this entire like lecture, right? Is memory, right? And like how objects in memory work, right? And like how if you point to the same thing, if you make different things reference the same object in memory, and if you change one of those things, if it's mutable, it's going to change everything, right? And so like all of this should make logical sense, right? Like I've never done these examples before, but like if you understand how the memory works, then you understand what this would return, right? So let me know if that all makes sense. If it doesn't, please stop me. So we'll go through and we'll go ahead and like oh god damn it, that didn't work for some reason. Oh fuck it. Anyway, okay, so let's go ahead and talk about this second one and why this too may be bad. Can anyone try to explain to me why this also is bad? This is a little more tricky, so don't feel too bad if this one doesn't catch for you. So here, if we do hash 1, matey, where we can get?
So it would just be an empty.
An empty what?
Empty hash.
Empty array.
An empty hash. Not an empty hash, but an empty something.
Sorry, an empty array in the hash.
Yes, exactly right. Yep. But okay, now if we key into hash, where we can get?
If you key in that hash, it's just going to be an empty array at that key. Well, the default hash sorry, the default value at any key will be an empty array right now.
Yeah, but if we just key into hash itself, if we or rather if we just call that, you can see it's not there, right? And you can literally see in the lecture note, right? It says also bad does not store keys, right? And so it doesn't store keys, which is quite interesting. So like that's the problem, right? Like now we do this. Let's you know what? Yeah, let's why don't we do this? Why don't we do hello, okay? And then Dom, I want you to tell me what is this going to equal? If we key into hash at 3. Or Lorraine, you can do this one too, actually. Tom?
It shouldn't work.
What's up?
Like it shouldn't work, but why?
Well, no. What are we gonna get back? What's the return value here?
Would it be just an empty?
What?
Empty array because we're evaluating to the block again.
You're fucking
like a new
right.
block.
You are totally fucking right. You totally understand. That's really fucking good. That's exactly right. So can everyone see that? In fact, here, Anthony, what does this equal? Anthony?
Did you type?
Yes. Yeah. Sorry.
The last thing I can see you type is try.
Hash key into 1.
It would just be hello, right?
Nope. Incorrect. Lorraine, you have an idea? Maybe.
Go.
H.
Wait, what? What'd you say? What would it be? Maybe?
It would still be the same thing, wouldn't it?
What do you mean by the same thing? What's the same thing?
Hash 1 at hello. It's hello. Still be hello, wouldn't it?
Nope. That's what Anthony said. Jeffrey, you have an idea?
It would be just empty array.
Fucking right. Okay, so far Dom and Jeffrey, you guys get this. That's what I'm getting here. Dom, can you explain why it's an empty array?
We're evaluating a new block.
Yes. Why are we evaluating a new block?
Yeah. So we're doing hash new with a new block that has like a new empty array.
Why are we doing a new block?
Because every time we're
So, Anthony, do you want to explain to me what hash 1 is going to give us now? What'd you say?
So this is saying hash 1 is equal to hash 1 plus an array of hello. So it should still be an empty array, right? Because we're initializing with the hash.new when we run hash.
Nope. Incorrect. All right. Matey, do you want to give a shot at explaining why we actually got hash 1 equals array of hello back this time?
I've never done that before, so I honestly have no clue.
Because the shovel doesn't mutate the array, but the plus equals does.
It's or actually the other way around. This is an assignment. This does mutate. The shovel does mutate the array, but what happened was this. So I'll explain. Yeah. This is an assignment, right? So when we assigned hash 1, now if we look into the hash, if we key into it, we can see 1 equals hello right there, right? But when we shoveled into this, so again, just like Dom was saying before, right? So what this block of code means is that anytime you have something that wasn't defined, right? Anytime you're keying into a value that isn't defined, then it's going to call the default block of code, right? It's going to run this block of code and return whatever the return value, the yield value of this block of code is, right? Which in this case is a new empty array, right? And then what we did here is that, right? We did hash 1. Hash 1 wasn't defined on line 5, right? And then so we returned a brand new empty array, right? And then we shoveled into that brand new empty array hello, right? But then we never saved that value to hash1, right? We never saved it to hash1. So then when we called hash1 again, of course it equals nothing, right? Because like we never said hash1 equals this value, right? We just said return a random array that we just made right now on the spot, and then shovel into that random array hello, and then discard it, right? Do nothing with it, just like let it go. And then once we have hash1 here again, and this is an empty, it's like, okay, so what does hash1 equal? Well, it doesn't equal anything, right? Because we never set it to a value. So then it says, okay, so let's run the default block of code again. We ran that default block of code, which has an array inside, right? And so with that array inside there, we have, it returns another default array. But you see, the pivotal difference is, yes, like you said, Lorraine, there's a fundamental difference between this and this line, right? This was just mutative. This one is assignment, right? And so here we're saying hash1 equals hash1 plus hello, right? And like, what is hash1? Hash1 is an empty array, right? What is an empty array plus an array with hello inside? Well, it's hello, right? And so like we said, hash1 equals hello.
You cut out.
What'd you say? I cut out. Is that what you said?
You're okay.
I'm okay.
Yeah, please.
Okay, yeah, Dom, you heard me fine?
Hello.
Yeah.
Wait, Matey, what's up? Matey, can you hear us? Matey?
Can anyone hear Ben, or is it just me?
I can hear
I can
Ben.
hear Ben.
Yeah, everyone can hear me fine.
I can hear Ben.
Yeah, but I imagine he can't hear any of us. Let's see. Yes. Everyone can hear me except you. All right. So Matey, let us know if you see that. Let us know if you see this. Okay. Can you hear me now? Maybe. Matey, is your headphone plugged?
There we go.
Okay, cool. Awesome.
No, it was Discord.
Yeah, Discord sucks. Let's go back to Slack. Okay, cool. So.
No, God, no.
All right. Yeah, okay. All right, cool. Yeah. So basically, leaving off where I was, what did you hear last, maybe?
I honestly don't remember. I all of a sudden panicked and tried to figure out what's going on.
Awesome, cool. Okay. Yeah. So basically, long story short, what I was saying is that the reason that this hash right here is different from oh, you're back, Delabor. What happened to you? You wanna tell us where you went?
Bathroom.
Yeah. Power outage. We had a storm.
You guys come up with the most creative excuses, I have to say, right? Like the most
Dog ate
random
my
shit.
mouse.
Yeah. Yeah.
My dog won't get on my keyboard.
I know, right?
I can't code the whole week.
Yep. That is like exactly what it sounds to me, right? With these excuses that you guys say. It's just like, what the fuck? Anyway, okay, cool. So yeah, so basically what I was trying to say, Dalibor, you can just see the recording later, right? And you'll catch up. But anyway, so for this specific part, I'll just rehash real quick. Haha, we're talking about hashes, now rehash them. Anyway, so basically with this hash right here, we have a block of code that runs as a default value every single time that something's not defined in this hash, right? So whenever we key into something that isn't stored explicitly in the hash, it's going to run this block of code and return whatever the return value of that block of code is, right? The yield value of it. And then that's going to be, in this case, an empty array, right? And so then when we go here and we do like hash1, shovel, this hello, right? Then like, we shovel, we create we return a default array and then we shovel into it hello, but then we don't save it to hash1, right? And then so if we call hash1 again, it's like, well, what is hash1? Well, it's not anything, right? We didn't save anything to that. We returned the default array last time and we shoveled something into it and then we just threw it away, right? We didn't do anything with it. So what do you want me to return? I don't have anything that's stored as the value that maps to hash1, right? So I'll just call this block of code again, right? I'll just run that again and return whatever that returns, and that returns an empty array here. But the fundamental difference is on line 8, when we do hash1 plus equals hello here. Well, then what's happening is it's saying hash1, as you all know by now, equals hash1 plus hello, right? And hash1, what is that? Well, it's not defined, so then it calls this block of code, it runs it real quick. It's like, all right, hash1, I'll just return a default array for that, right? So it's really hash1 equals default array, an empty array plus an array with hello. And what does that equal, right? Well, that just equals an array of hello, right? And then in this critical difference, this is assignment, right? And so what we're doing is saying hash1 equals empty array plus hello, which equals array of hello. And so now hash1, if we key into it, it gives us back hello because now it's defined, right? And so now it's hello. So does everyone understand that? Let me know if I'm going too fast. Really, tell me to slow down if I am. But like, hopefully that does make sense. So that too is bad, right? That's also bad because like it does not store keys, right? And so now let's talk about this last really fucking weird looking thing that like maybe you have all seen before. Raise your hand silently if you've seen this before. Dom?
I am raising my.
Okay, awesome, cool. Has anyone seen this before besides Dom?
I think there was an exercise where
I've
they
used it like
used
once.
this.
Okay, so you've all seen this before. Great. Okay, does anyone want to explain to me what this does and why this is better than the rest? Dalibor, how about you?
No.
I can do it.
Awesome, Matey, go for it.
Every new key, every new key of the hash, its default value will be a unique array.
Every new key of the hash, its default value is going to be. It's not. Yeah, every new key. Yes, default value is going to be an array. That's correct. But what specifically is different about this than the last way that we did the hash.new? This. Whoa, oh my god, what the fuck is that? Hash.new.
It points to different objects. Even though it's the same default, like even though the default array is empty, it points to different objects, so the object ID will be different.
In both cases, you're right. The object IDs are different for both cases. This in the line 2, this array that we're creating here also has a new object ID every single time, right? So here, let me do it. Let's do hash2 equals hash.new this right here, and if we see this key, and then we'll do one.object ID. Then we'll do it again, actually, and you can see every single time we get a new different thing, right? If we do equals hash 2.object ID, this is false, right? We can see that at no time will this ever be true, right? Every single time we key into this, it does give us a new array, and that's also true of line 1, right? So both of them do give us a new object ID every single time and a new array that's making. But there's something else that's different about this this first line. Dom, you want to give it a shot?
So is it because that every time we with the key, like it automatically assigns it like a value? Well, in this case, it's like an empty array.
Exactly right. So the only difference here is that this automatically assigns the this whatever this value is right here to the key that you pass in. So why don't we try that right here? Why don't we do 3 shovels 4? Does anyone want to guess what this does, Anthony? By anyone, I always mean you, Anthony.
Yes, it would assign the third key to the value 4.
Specifically, the value 4, or an array with a 4 inside, or whether you want to say.
With 4 as the default value.
No, not quite. The default value is this term of the default value is quite confusing to y'all, it seems. 4 is definitely not a default value, right? If there is any default value, it's actually whatever this block of code returns in line 1. Whatever that block of code returns is what the default value is, right? And but this 4 is not a default value, but like it certainly may be part of the value. Matey, you want to tell me what this returns?
It would be an array of 4 in it.
Yes, exactly right. Perfect. Awesome, great. And then now if we just type hash, what are we gonna see here? Matey?
I'm sorry?
What are we gonna see?
It's still loading. All I see is hash 3.
Yep. So wait, what are we gonna see? Hello?
So what were you going to type? Because it just says hash.
Yeah, exactly. That's what I'm going to type. That's exactly what I'm going to type.
Oh, so what am I going to see? I'm going to see an array, and then it's going to have empty array, empty array, empty array, then array of 4 in it. Wait, yeah, whatever's at the fourth spot, 0, 1, 2, 3, 3. Yeah, so 4 over will be an array of 4.
No, this is a hash, not an array. Hashes are different from arrays, so we're not going to see that. Jeffrey, you want to tell me what we see? Jeffrey.
For what we see for hash.
Yeah, exactly. Yep.
I think since it has called the value. Wait, sorry, I'm having a tab. Hash. Since it's called the value of 2 and 3, I would say that it'll be an empty array. The value of 2, and then at the value of 3, it'll have 4.
I'm so confused.
In array
form.
form.
What are you reading right now? Where are you?
You're on line 10, right?
Yeah. Where are you getting?
Yeah. So it's super confusing because you have like one variable that's hash and one variable that's hash 2. So I'm like having to look around.
This is just hash.
So
this is the original hash.
Yeah. So I think, I'm not actually sure, since you called hash2.objectID, those might be initialized as empty arrays. So I think it's possible that...
Forget anything with hash2. Hash2 has nothing to do with hash1, right?
No. That's what I'm saying. Hash, you see hash object...
Oh, yeah.
Yeah, of 2.
You are fucking brilliant. That's a great catch. Yeah, I love that. Yep, perfect.
Yes.
Cool.
Yeah, so I'm not actually sure whether or not that affects it, but if not, it'll just be 4.
Okay, yeah, you're totally right. It does actually affect it. Really fucking.
It does?
Catch.
Okay.
Really good catch. That's
Cool.
awesome. That's good.
Yeah.
Explain when you did that.
You see the problem now, right? Like hash 2, yeah.
Yeah. Well, I'm really fucking impressed that you caught that. That is like extremely.
Yeah.
That means you're really paying good attention here, which is awesome. Because that's fantastic.
Yeah,
but you're totally right. It is in fact 2 is an empty array, and then 3 is that. That's awesome. That is like the most impressive thing that's happened all lecture. I'm very impressed that you're paying such good attention. Good, man. You've been crushing it so far. I think you gotten like almost all the questions right, which is which is quite impressive. So that's good. Good stuff. Hopefully that makes sense to everyone else. So yeah, the key difference between here is, again, there is actually no fundamental difference, right? In line 1, where we're doing this like thing, this is just a block of code, like any other block of code, right? It can do whatever the hell we want it to do, right? But the only kind of tricky, interesting thing about hash blocks of code is with any block of code, I mean, maybe I'll just make an example here, right? Like you can see here, we pass this an n, right? This can take any amount of things, right? We can, on line 67, we could do A, B, C, right? We can do A, B, C here, and then we'll just do placeholder, hi, name, or let's just do Jeffrey, hi, name, and, B, right, and like something like that, right? And then we're going to call this random method here, and then we're going to go and, oh god, there we go. Okay, cool. Holy shit, no method n for, right, because I renamed it. Yep, okay, cool, there we go. And then, yeah, so we get hi, Dom, and Jeffrey, right? And so you can see this is kind of interesting, right? Well, weird, like this this block of code seems to take three like parameters in it, right? But then, yeah, like it doesn't actually, it doesn't seem to actually like care that we didn't actually pass it this like C or anything like that, right? And indeed it doesn't. So blocks are interesting in that they take an arbitrary number of arguments, and you can say I want these arguments, or you cannot, right? Like here we're passing it 2 arguments. There's no C, right? So there is no argument C. But then we could just say fuck it. Who cares about any arguments? I'm just always gonna say hi to Dalibor, right? So we'll just say hi Dalibor and Lorraine, right, or something like that. And then like we just throw that in there, and you know what? It's cool. Who cares that we're passing it 2 arguments? This block doesn't care. It just says, yeah, that's cool that you're passing me shit. Like I don't care about that. I'm not gonna do anything with it. And then it's just gonna run this, right? And that's kind of the same thing that's happening with this hash here, right? So if we look at this hash, what we see is that now this block of code is quite interesting, because we have in this case, in that second case, right, like hash.new, here we didn't pass it any block of code. We didn't pass it any arguments, right? But in the second case, we do pass it a h and a k, right? And then we do h of k and this like crazy fucking shit, right? Like, and yet like both of them work. Well, it actually turns out that for every single block of code, this this like hash class, right? Let's write like hash class here, and then let's do like def initialize, and then in here we're gonna have like a h, and then we're gonna have a or fuck it, whatever. What this is like the length? No, there's no length of a hash. This is just default value, right? Default value equals like a nil or some shit, right? But then and then what is it? And then in here we've got like a yield f block, right? Maybe we'll take in block, right? We'll do proc in here, and then we'll say f proc. Then we'll do f. Okay, let's say this, right? It's like if, oh fuck it, it's not even in def initialize, right? It's in the def like this method, right? You probably have seen this by now, maybe not. Yeah, you have actually in Foundations. You've definitely seen this. So this is like the what, like when you have an instance variable of this, right? And it calls this thing f self of and then this takes in like a key, right, or something like that. And then f self of and then this actually should take in the proc. No, actually, this will just call the proc here. Let's save this proc is actually a proc like so or something like that, right? And then what we'll do in here is we'll say f key unless key in here. So unless this is actually stored to value, what we'll do is we'll return prc.call and then we'll call, and then we're going to pass it two things, which is really interesting. What we're going to do is we're going to pass it self, and then we're going to pass it key, okay? And then we're going to run this block of code with whatever the hell's in there, right? So hopefully this makes sense to you all. It might be a little bit confusing. Basically what we said is, when we made this hash, right, we passed it in a block of code, right? And that block of code, we just saved it to like an instance variable. That's called like proc, right? And so we save that block of code such that we can use it later. And then when anyone else keys into this hash, right, we're going to call the key in method, right, of this hash. And then, they pass to the key, right? And then we say, okay, unless there's a, if there's, you know what, we'll do an if and else, right? If there is self.key, then just return self.key, right? Return whatever the hell that equals, right? Return the stored value here, right? And then if that does not exist, right? If that's not in there, then we'll call this block of code if the block of code exists, right? If prc, right? Else if let's do this, right? Else if prc, then call this else do default, right? Do default, if that makes sense to you all, right? Because like a hash can also have this default value thing, right? The hash thing, right? And so basically like it goes through this logic. In fact, I'm not even sure if this is an order it goes through. That's something we should check. This is just for like, example purposes, right? This is not actually how the hash method is actually written, right? I literally just invented this right now. So in this initialize, we have a default value, right? You can pass it just like this, right? In this pry that we have right there. If that, but you can also pass a block of code, right? And if you pass a block of code, it's going to say, oh, do we have a block of code? If we do, well, first, if the key exists, obviously just return the key's value. But if it doesn't exist, then let's call the block of code, and then let's pass that block of code two variables, right? Two arguments. And then if there is no block of code, then fuck it. Let's just return whatever the default value is. If there is no default value, just return nil, right? Which is what a hash normally does, right? If you do hash.new, then you do hash nil. Nil. It's like this. You get nil back, right? And so in fact, we can our own hash. Why don't we just call this our own hash right here, right? And we're just gonna make my hash equals our own hash. Right, dot new, and then let's see what that does, and then my hash2 equals our own hash dot new, and then we're going to pass this a block of code. We're going to pass this a block of code that does something like, I don't know, f self key. Whoa, that's trippy. Yeah, this is actually not going to work because this is going to be oh, that's real trippy. Anyway, okay, yeah, this is not gonna work, but you could literally do this, is what I'm trying to get at. Anyway, because this is like a call to this, And this may actually just return nil at the end, and it would be fine. But this is kind of like self-calling, which is like really trippy and shit. Anyway, we're not gonna get too far into that. But the idea here, hopefully you understand, is that this block of code that we have here does take in 2 arguments, right? And you don't have to call those 2 arguments, right? You can emit them in a block of code, as we did right here, right? We can emit these, even if you pass it 2 arguments, it still runs just fine, right? But you can specify that you do want those 2 arguments in your hash, right? And so you can do this, right? And so what are these 2 things? Well, they're always the same, right? This hash is always the hash itself, right? It's literally the self that we're passing here, right? And then what's that second one? It's the key that you literally just keyed into, right? And then this block of code will do whatever the hell you want it to. So why don't we try that? Why don't we make a block of code that does anything again, just as we have been doing in the past. And then so here we're going to do a block of code, let's say hello equals hash dot new, and then here we've got h, and then we got k. You know what, fuck it, let's do do, and then h, k, and then on the second line we're going to say puts hi everybody, I'm a hash. And then on the next line we're going to say wee, and then we're going to go and we're going to say you know what, fuck it, why don't we do something like h of k equals bunnies. Great. And then we're going to say random value 42 end. Okay, cool. So we're going to do this. Now, this is an empty hash. Now, Dalibor, do you have any idea what this is going to return? Dalibor, 5, 4, 3, go.
I have no clue.
Alright, cool. Good honesty. Dalibor is the most honest person here. That's good. Matey, you have any idea?
Everything you just did there.
It's gonna run that all the things I did here. That's true. What's it gonna return?
I mean, it's going to return all of it, isn't it?
Um.
Once you do hello 0, it doesn't that.
It doesn't actually return everything. It's gonna do this puts. You're gonna see this for sure, right? Are you gonna see this we there?
No.
Okay. Are you gonna see this? This HK equals bunnies.
Wouldn't the result just be bunnies then?
I don't know. Is it? Jeffrey, what do you think? Jeffrey? Muted, Jeffrey. Jeffrey is muted.
I was definitely talking. I think it would set the value in the hash of k being 0 to bunnies, but then it would also it would return 42, and I can't quite place where that 42 would go right now, but I think it might write over the hash value.
That's really
So
close.
you're basically doing the same thing again about implicit and explicit return. So in this case, it's going to be 42 because it's the last thing that you had in your block.
One second real quick. Sorry, we were getting some feedback
Yeah,
from
yeah.
Angela. Angela, if you could just mute a little bit, but it's fine now. Thank you. Dalibor, you want to repeat that one more time?
Yeah, so you're going to get 42, right?
Yes. You're doing great. Yeah, you're all doing fantastic. Yeah, we get 42 back as the return value. That's great.
Nice.
That's really good. And Jeffrey, you were really good too. You guys are using excellent logic here. This is fantastic. You're never gonna see code like this, right? I've never written code like this before. Nowhere in the real world where you ever see things like this. But I want you to understand the fundamental premises, right? And so, like, Dom, can you explain to me what hello? If we just type hello, what we're gonna get there?
0 equals 42. I mean 0.42.
Nope, incorrect. Anthony?
I honestly don't know, but if I had to guess, I would guess 42. but I have no
Wait,
idea.
haven't you already defined that in line 1, 2, 3, 4?
Yeah.
Oh,
So
is it gonna be?
what's cuter than 42, Dalibor?
Sorry, can you repeat that?
Yeah, what are we going to get back? What do you think we're going to get back when I type hello here?
You're gonna get the bunnies line.
Specifically what? Like, what with that line? Like, what is everything I'm going to see? Hello is a hash, right? So, like, what am I going to see inside that hash?
Or it can be nil, right? So,
Oh, is it gonna be 0 to bunnies?
You might be right. What's up? It's 0 to bunnies. Bunnies! So, does everyone understand this code? Does anyone not understand this code? I know most of you don't understand this code. Hopefully you do now. Dom, can you explain why we got what we got, everything?
Yeah. So, like, I go through the whole. Let's pretty much ignore what's happening and just does the hi everybody. That's the value of 0 to bunnies. Since the last thing that we're like running is 42, just outputs 42. But when we do call like specifically when we call the whole thing, since we set 0 to bunnies, then it's gonna say like hash 0 to bunnies.
Exactly right. That's perfect. Yep. Good job. So this is a little bit tricky, but like, you know, you should get the idea here, right? Like this is like I told you, right? Like H is the hash itself, right? K is the key that we passed in, right? And then whenever you set like that equal to something, what do you get? Well, you literally set that, right? In the hash, right? And so we set that equal to bunnies. But then what's the return value of a block, right? It's always the last line that you evaluate, right? It's 42. So what happens when you do hello 0, right? Well, it says, okay, is there a value that's associated with that key of 0? Well, there's not. So what am I going to do? Well, I'm going to run the default block of code, right? And I'm going to return whatever that default block of code returns, right? Well, what does that default block of code return? It returns the last line, right? So it returns 42 as a result there, right? But what does it do? It actually runs every single line of code inside that block before it returns that last value, right? And what did we do? Well, on that third line inside that block of code, we set the key of that hash to bunnies, right? And so that's what happened, right? So now the key, you can see, is actually set to bunnies, even though the return value is 42, right? All of this makes sense. We knew all these points before, right? You all have heard me say this many times during this like lecture. If you're thinking about this like critically, you should be able to think of these things, right? This is not like magic, right? Like this all just logically makes sense. I came up with this random example on the spot. I've never done this before, but like if you have the logic in your mind, then you understand what it's going to return, right? And so now knowing this, we can go back to the hash of like hash.new, and then here we have the h and the k, and then we have the h of the k, and then we do equals an array right there, like so, right? And then with this thing, now hopefully you all understand why this is actually doing what it's doing, right? If we do a hash of a 0, right, that's going to, 1, it's going to return this empty array just because by happenstance, whenever you do an equals assignment operator, that assignment actually returns whatever the value you assigned it to is, right? If you do var equals hello, well, the return value of that line is actually hello, right? And so same thing here. The last line evaluated in this block of code is h of k equals an empty array, right? So it returns an empty array because that's the last line of code that was evaluated, right? Because an assignment returns that as its last line of code, right? But at the same time, what it does is it also sets hash 0 to that thing, right? And if we do hash 1, and then here we do like hello, like so, and we look at the hash, then we see, oh, that equals actually a 1 with a hello inside there, just like that, right? Hopefully that makes sense because it said, okay, well, does hash 1 exist? Well, it doesn't exist. Let me call this block of code. Let's return what it returns. It returns that array. And then it also sets this equal to that exact same array, But then with that array, it says shovel in that hello, and then it shovels it in to that exact same array that you actually returned, and then that you returned and you set this equal to, and then such when you look into hash, it says that, right? Now let's look at another example, right? Let's reset this. Let's go back. Let's do system clear, and then let's go and let's do another like hash, and we'll do hash equals hash.new, and then in here we're gonna do an h, and we're gonna do an k, and then we're gonna do an h of k equals an array like so, and then in there what we're gonna do is fuck it, we're gonna actually do something else. We're gonna do a, maybe you've seen this, maybe you haven't, but we're going to do a puts hello like this, right? And then, now, can anyone tell me what this is going to give us? Dom.
Just loading. Oops. I'm not familiar with the semicolon, but like
semicolon is here. Let me show you what the semicolon is. The semicolon is just how you write multiple lines on the same line for Ruby, and so it is identical to doing this. This is something that you may see in your code. You usually don't because like it's not like good Ruby style. No one does that. You just like write your code on 2 different lines, but you can do the same thing like so. So these 2 things are synonymous, if that makes sense. So cool. Now go ahead and do that.
So, something?
Sorry, what were you saying?
Okay, so it would just,
what is this going to return?
hello?
Okay. Not quite. It's, there's a trick here. There's a trick here. I've tricked you. What does a puts return as its return value? Does anyone know? If you watch my video lectures, you would know. I make one about the difference in like intro about the difference between P inputs. Does anyone know what the difference between P inputs is? Matey, Jeffrey, Dom, Ben, Dalibor, Anthony. I'll go last if any of you can't figure it out. Woo.
So when you do puts hello, it will just write the word hello. P, it'll show it in a string, wouldn't it? Or did I just do that back?
No, they both do puts hello to the terminal. They do both like print it to the terminal. Okay, so I'll just tell you the difference is it's a slight. Yeah, go ahead, Jeffrey.
Sorry, puts is .to string.
Yes.
.2s.
Yes.
That's really it.
Yeah. What is P? Do you know?
Just printing it like it's in those single brackets, like just alt chars.
Nope. Actually, it's something different. It's P is actually
Oh yeah, it'll print like the data.
Yeah, exactly. Exactly. It's actually this. It's inspect, and then this is 2s, and so. But you won't actually see those escape brackets in there. So P will actually take care of those escape brackets. But P hello does this, and then puts hello does this. And then there's something else here that's a little interesting that you may all know. But basically, these are methods that you yourselves will write on all your classes. They are basically defined on every single class that you will ever like use that's in Ruby itself is a .2s and a .inspect. And we'll talk about this later because this lecture has gone on way too long. There's like still so much more, but this is just like it's not sticking for you guys yet, so we're going through it a little longer than normal. But basically what happens here is this inspect is something that the computer basically uses or you use to really like look into like what your code literally is, and a 2s method is so this is for you to like help you debug. 2s is more so for like having pretty code to like print out to like a human, for a human to parse, right? Someone who's going to be an end user of your code when they're reading it. So puts is like the human readable version, right? And then P is the and then there's also print, right? There's also print hello, and print hello also actually does 2s, I believe. Yep. And then it just doesn't have a new line break. Puts has a new line break as well as the 2s. And then so anyway, so basically that's that. But like P specifically does a hello .inspect, which is like for your use cases. But with this, there is one special tricky thing here that I've shown you all. That now maybe Dom, you can tell me what does hash of 0 return?
What did I say before that? I said that it will. So before that, I said that it's just gonna return hello, and there's more to it.
Yes, yes, you were incorrect in that it would return hello. It will print hello to the screen, that's certainly true. But what will it return as its return value?
Oh, I got it. Okay, I mean, I think maybe. So would it?
What do you think?
I'm thinking whether it's like nothing or like no, or whether it's
I like it.
or whether it's like the empty array.
I like it. I like it. Let's find out. Guess what? You're totally right. The return value is nil. Perfect. Good. It does print hello to screen, but you can literally see, right? I showed you that, right? Like right here, it puts hello to screen, and then it returns nil as its return value, right? So obviously it would be the same thing here. What's the last line of code that was evaluated here? Well, it was puts hello, right? And what does puts hello have as its return value? Puts always has as its return value nil. It prints something to screen, but it has nil, right? And like you all should know this, like because any of you who are confused with like return versus puts, right? Like Dalibor, I made this video for you as literally the first video I ever made. I talked about this in that video, like in the intro programming in the beginning, right? Puts returns nil. P returns, in fact, something different. But anyway, yeah, hopefully you all get that idea now. Cool. So now if I key into hash, Anthony, what am I going to see? If I just write hash.
Oh, I guess no, because you're not really returning anything.
Totally wrong. Jeffrey? Jeffrey, you're muted again.
I think it'd just print empty hash because it doesn't have any values.
It's gonna put nope, totally wrong. Maybe.
Yeah.
Hash, wouldn't it show a hash key of 0 equals empty in an array, and then it will put hello. And then it would say no.
Really close, really close. You got the first part totally right. Really good job. It
Yeah,
does.
but then it would say hello.
It does not say
like
hello.
it did.
No, it does not say hello. It actually just does the 0 with an empty array. So that was quite good. Very close. Dom, do you want to explain why it did not say hello again?
It's like can you scroll up?
Yep. There you go. I'll scroll all the way up for you. There you go.
Yeah.
Does anyone know? Dalibor?
Well, I think that I agree. Whoever said that 0 will evaluate to an empty array.
Well, that part was obviously right. I already wrote that out there. That's definitely true. Well, why does it not print hello again?
Why doesn't it print out hello?
Yes.
Because you're not. Oh, I got it. Because you're not referencing the hash at that specific value in which you put that block of code. You're just looking at the hash overall.
Okay, so if I do hash of 0, what is it going to say? What do you think, maybe?
Hash of 0 is going to execute the hello again.
Nope.
No, I just said empty array.
Dalibor, what do you think?
Well, empty array, we said it like 30 seconds ago.
Okay, and then so why doesn't it print a hello?
Where have you declared that the value is print hello? I'm not seeing that.
Okay. So how about if I do this? Hash of 1, Dalibor, what is that going to return?
I'm unmuted. So hash of 1 will return nil, I think.
Okay.
Oh, so is it only when we're assigning values that we put hello and?
Or is it the other way around?
Oh god, you guys are so confused. It's really concerning. Yeah. Okay. So let me explain this to y'all. Okay. Yeah.
Can you please hit enter?
Yes, I will hit enter. Boom, you get that, okay? I'm going to hit enter for 0, 2, right? Boom, you're getting an empty array. Can anyone explain that to me? Okay, I'll explain it to you all. Okay, yeah, so basically what happened here, right, is, again, what does a default block of code do for a hash? Well, it only runs that block of code, right, if there is no value defined in the hash for that key, right? And so, what's up? What'd you say, Dom?
Isn't that what I said? That we're only putting hello when we're saying like new values?
When we're assigning a key, that's not true. No, how about this? What if we do 3 equals 4? What are we going to see? Or 3 equals 5? Are we going to see hello?
3 equals 5. What do you mean? I don't know. It's like, just looking.
What are we going to see there? Dom?
I could not explain my answer, so I'm not gonna like. I mean,
yeah.
So if you have just assigned 3 as a key and 5 as a value, so if you would type hash again, you would get like, let me see, 1 to third element of your hash, where 3 will equal to 5, right?
Yes, but that's not what I was getting at. What I'm getting at is, Dom, what you said specifically was when you assign a value is the only time we run the block code, and that's technically incorrect, right? Maybe what you meant to say would have been correct, but that itself was not correct, right? When we assign a value to the hash, nothing fucking happens. We just assign the value to the hash, right? It's specifically when we try to key into the hash at a value that is not defined is when we run the block of code, right? So when we key into something that is not defined is when we run the block of code, and the block of code is what puts hello, right? But once we run that block of code, it just so happens that inside that block of code, we are defining that key to something else, right? And so when we define that key to something else, then that thing is no longer going to call that block of code because it's defined, right? The block of code only runs when it's on a key that is not defined, right? If it is already defined and set in the hash, it's not going to run to anything. So that's why it puts hello, right? When you are actually calling into a key that is not defined, it runs hello, and then it returns nil, right? Because puts returns nil, right? And then when you run that key again, it's just going to return whatever you set it to in here, right? On this line right here. We're going to do one more quick example for y'all. So we're going to go back, we're going to do this hash, and then we're going to do what hash equals hash.new, then we're going to do a do block here, and then we're going to, oh god, fuck it. Okay, let's do that again. Let's do hash equals hash.new, and then we're going to do, and then we're going to do an h and a k, and then, you know what, yeah, I'm not going to confuse you guys too much. Okay, cool. And then what we're going to do is we're going to do h of k plus 1 equals, what's cuter than bunnies? Squirrels. Squirrels are cuter than bunnies. Alright, cool. And then we're gonna do, puts, please get this right, and then we're gonna end that right there, and then we're gonna go, and then we're gonna do 3 right there, okay? Dalibor, you want to tell me what this is gonna give us?
Yeah, you're still typing. It says hash 3.
Yep.
Okay, so if you press enter, you're gonna get just 3, right?
What are we gonna get?
Like an empty array, right? And then you would do hash.
Why would we get an empty array?
So so it's not empty array actually. So it's just
Cool. Anthony, you want to give it a shot?
What was the question again?
If I type hash of 3, what am I going to get?
The return value?
Yes.
gonna guess nil.
Yes. Perfect. Good. And then it's gonna also do a puts. It's gonna print the "please get this right" onto the screen.
It's gonna say like please, and then please get this right, then say nil.
Perfect. Perfect. Good job, dude. Good. Awesome.
It puts isn't returning anything.
Yes. Perfect. Okay, Dom. If I type #3 again, what am I gonna get?
We're gonna get in this case it's k plus 1.
Okay. So what are we gonna get?
So,
what am I gonna see on the screen, Dom?
yep. 1 sec. So okay. So you set 4 to squirrels.
Okay.
And then. So would it be the same thing? I guess. Again, please get this right.
You fucking got it right. That's awesome. Good job. Matey, what are we going to do if we do #4?
The exact same thing.
What are we going to get here, Matey?
Please get this right. Oh, wait, 4?
Uh-huh.
Same thing?
Nope.
Since we're ready.
Jeffrey, you're muted. Oh my god, you're muted again, Jeffrey.
#4, yeah, so that'll also print nil, and it'll set the value of #5 equal to squirrels.
Nope.
Dalibor?
Dalibor. Yeah. Yeah, you're good. Dalibor, you want to tell me what this gives you? Oh god.
No.
Anthony? This is not that hard, guys. Like, seriously, just read the code I wrote. Like, is that you going to the bathroom, Anthony?
Dude.
Anthony, can you hear us? Oh god, we're so fucked.
He's stuck on the toilet. If you do #4, it would set hash at 5 to squirrels, then it would put please get this right, wouldn't it?
Nope. It actually just gives you squirrels. So, Dom, can you explain to me what #5 is going to give us now?
Yeah, since we already, with the last line, we set 5 to squirrels, so it's going to be squirrels.
Nope, totally wrong. None of you get this right.
Okay,
oh,
so hold on.
Yeah,
I got it. I got this.
You go.
Yeah, no, I'm sorry because that wasn't a default value. So, I mean, that wasn't. Yes. Okay. So.
Oh god, we're fucked.
Okay, no, we're good. The default value at this was the please get this right, right? But if you do once you did #3, it set #4 to squirrels. Once you did #4, it set #5 to squirrels. So if you skip #5 and go to like #7. It'll say, please get this right again, and then it'll set #8 to
hang on. One
thing
thing at a time.
We already have it set, so we're not sending anything.
Yeah. Matey, what is a #5? What is this going to return us?
Squirrels?
Nope.
That we should get it right.
Yes. Good call. It says, please get this right, and then returns no. Matey, can you explain to me why that happened?
I got nothing.
Cool.
I don't know why I'm so confused.
Alright, hey Dom, if we write hash like this, what are we going to get? Can you tell me what we're going to get now?
Hash without nothing?
Yes, exactly. Just the hash. What is the hash going to show us right now?
Okay, let's see. So we got our 4.
Oh, so you're a sneaky one. Oh my god,
sneaky. I wrote
this
2
is
lines of code.
Absolutely not fair.
I wrote 2 lines of code, dude. Literally 2 lines of code. It's not sneaky.
It's like now we are expecting to see 3 and, 5, but you added 1, so we're gonna see like 4 and 6. Is that the answer?
Yeah, obviously. That is like, I wrote that there, and I told you that I was
super sneaky.
Like that is not sneaky at all. That literally is right there in the code. If you read the code, you should just read the code, right? The code's right there. So, Dalibor, what are we going to see?
What happened here?
Yeah, so you're gonna see probably that 4 equals to the whatever first thing you wrote. What is it? Squirrels, and then that was the next line 4, and then you're gonna see 6, and then again equals to squirrel.
Fucking right. Perfect. Dalibor, you fucking got it right. Everyone, do you understand why that happened?
Yeah.
I was about to. Okay. Okay. Yeah. Yeah.
Awesome.
I
What were you gonna say, Dom?
meant that I didn't finish like talking. I don't know.
You were gonna say the same thing as what you're trying to say, right, Dom?
Like, yeah, I just started saying 4 equal to.
Yes.
I don't know.
Sorry, Dom. Absolutely my bad. I was just about to say that this was a sneaky Ben's example, and I just wanted to say that. And then he got me into answering. Sorry, my bad, Dom.
Yes.
Yeah.
Dalibor, apologize. That's all your fault. All right, good stuff.
You ruin everything.
Awesome. Matey, you get it? Does it make sense to you?
So is it that the odd ones were executing a line of code, but they weren't storing anything at the key value?
Exactly right. Yep. And what, in fact, were they storing?
Sorry?
What, in fact, were they storing? Were they storing anything? When
No, they were just they were executing the code, but then they were storing at the next what they were saying. So it's k plus 1. So they were saying, okay, you know, at 5, you're going to say, okay, so 6 is now going to be squirrels. Or if you did 7, it would say 8 would be squirrels.
Exactly right. Yep. And that is, in fact, saved in the hash, right? So can you explain why when we did hash of 4, it did not save hash of 5?
Because, actually, is it because the default value is just squirrels?
It's no, it's
and that block isn't there anymore.
No, the block of code is only called if a value for that key is not found inside the hash, right? Does that make sense?
Yeah, so that's what I'm saying is it's not there because we already called, or when we called hash 3, it went ahead and now set it to squirrels instead of the default value being whatever everyone else had.
Yeah. So wait. So okay.
It didn't have the hk plus 1 to execute when you call explicitly hash 4 right there.
Exactly. Yeah.
It's just the value squirrels at that point.
Exactly. Yeah. If a value is defined for a key inside the hash, it will just return that value, right? It will not run this block of code. If, however, it does not find a value in the hash for that key, then it's going to run that block of code, and then it's going to do something. Now here's a real trick question, right? This is an actual trick. This should not have been a trick question so far, right? This should have been very straightforward. But here's an actual trick question. Dom, can you tell me what this returns? Or Jeffrey.
Mm-hmm.
Dom, you have an idea?
Is there gonna be like an error or something? Because we can't.
Awesome. Good fucking
combine.
Yep. You are someone who is reading your code correctly. Really good. Exactly. It gives you an error, right? That's it. That's the stupid trick question. It's like not actually relevant. But I just want to see if you all were actually like thinking about this code, right? Like don't just like the whole point that I'm trying to get here is like don't just try to memorize something, right? Don't just try to memorize this like block of code. Oh, hash.new h of k equals this. This is how I make a good like hash with a default value of an array, right? I have no fucking idea what this means, right? I'm just gonna remember it and like memorize it and write it. That's what everyone in the App Academy does, right? They never explain all this stuff. But like I want you all to be able to critically think about this and understand how it's really working under the hood and be able to do it yourself, right? And to understand like how these things would work, right? And like, obviously you're gonna get a type error here because you can't do H.
So going back to this, that one line of code is just setting a new array as the default value whenever you go ahead and call anything at a specific key.
Yes, exactly. Yeah. So what is this gonna return us? Maybe where are we gonna get here if we do this?
If you do hash 5, what are you gonna put into it?
Oh, dot concat.
Oh, where do you get a concat?
Dot concat array 1, 2, 3.
So when you return hash, you're gonna have hash at key 5 will have 1, 2, and 3 in it.
Fucking brilliant. Perfect. Yep. Really good. Yep.
This is actually more helpful than, despite how many bathroom breaks we've all taken, it's still been a better lecture than App Academies.
Oh, thanks, man. That means a lot. Yeah, I hope this is helpful.
Well, because they don't do this. They don't really, like, monotonously beat it to you in such a slow way so you actually understand what the thing is doing.
Yeah. Yeah, in fact, I'm pretty sure our lecturers did not actually know why this was working this way. I asked them, like, specifically afterwards. How I learned about this was I was like, oh, is this a block of code? Can you put any arbitrary thing in there? And they're like, who the fuck knows? So I tried it, and obviously it does work, right? It is just a block of code. So then, like, now I can teach it to all of you. But yeah, they were just like, oh, this is the way to do it, right? Like, you do a block of code, it works right. Like, the parentheses does not work right. The end. And just remember the block of code, right? But obviously the block of code works for a reason, right? And you should understand the reason why the block of code works, not why the parentheses and the block of code are just like these magic things that work, right? Now hopefully you all do understand. Hopefully this all does make sense to you. And now we will move on because it's like very late in Eastern Europe for all of you.
So I'm sorry. So one last question, and I think you did this right at the very, very beginning. With that block, though, you did use a semicolon, so you could technically reference a method by throwing an ampersand in there with that, right? So if you said h bracket k is equal to empty array, and then you add a semicolon, and then you can say something like, dot map or whatever, something else, and then, have all those arrays, whenever you reference a new hash, dot map something to it, or whatever, right away.
Yeah, that's a quite complicated thing. So let me try to write out an example to like maybe.
Yeah, sorry, I'm like partially bullshitting, but thinking at the same time.
Yeah. Yeah, I see that. Yeah, okay. So you're saying like, can we call like a random like thing in here every single time? Yeah, you totally could. We could do something like this, right? We could do h. This would be insane, right? But like you can do anything that you want, right? Like you could do this equals a k.map, and then in here we do like a fucking, I'm gonna write this out with the long way so it's better to read and like better style, because this is a style lecture after all. Not that we've actually gotten to the style part of it yet, but dot k dot, yeah, there's a whole new section of this lecture. Can you guys believe it? We're not even done with the first part yet. Anyway, k.map, and then in here we're gonna do a do, and then we're gonna do a l, and then we're gonna do something like maybe an l times 2, right? And then we're gonna end that, and then we're gonna end this, right? Yeah, there's no reason you can't do something like this, right? This is a method call in there, and so now you must be aware that in fact we can only do this on something that is in fact like an array, right? 1, 2, 3. Can anyone tell me what this is gonna return? Maybe.
The array is going to be 2, 4, 6.
Yeah, so what are we going to see returned here? What's the return value that we're going to see?
So it's going to be hash at 1, 2, key 1, 2, 3, and it will be in another array of 2, 4, 6.
That is, yes, that is correct. That is what the hash, if we typed just hash, that is what we're going to see. So I'll just type hash, and, or let's see, in this case, what do we do? Oh yeah, my bad. I did not actually even run it. Yeah, my bad. I should run it first. Okay, so that is correct. If we ran this code and then we typed hash, then that's what it would give us. But what will this return in of itself right now? What is the return value of just running this line of code? You're totally right that afterwards that is exactly what the hash is going to look like. So that's really good. But do you know what the return value here is?
Is it not going to return anything?
It will actually return something. In fact, it is going to return 246. Can you explain why it's going to return 246?
Well, because it's mapping. So you're saying the k.map. So it's executing the block code format.
Exactly right. Yeah. And specifically what it is we're doing the last line of code that's evaluated here is actually an assignment, right? It's h of k equals k.map. But as I told you guys before, right? The assignment is equal to whatever that thing is, right? When you do var equals 123 dot map L times 2, right? Like that. That equals this, right? It equals the same thing as if you literally just wrote this line, right? Var equals 5 returns 5, right? Whatever the assignment value is what the return value is, right? So they're all the same thing. And so you're totally right. That's what you get. Perfect. Hopefully that all makes sense to you. All right. Yeah. Besides that, I mean, we were going to do a whole lecture on like blocks and procs. Yeah, blocks and procs. Hopefully you all understand them. They're good stuff. Good to go. Do you all have questions? Oh, fuck it. I'll actually do a real lecture on this. Okay, so basically, blocks and procs are this fantastic thing in Ruby, which we've already been thankfully playing with a little bit, right? And so they're good to know. But like, basically, can anyone explain to me what a proc is? Dalibor?
Same as block, only it transfers it to an object, because blocks cannot be objects and procs can.
Yeah. That's pretty correct. Specifically, what a proc does is it is just a object, right? It's like a class proc, right? And then in here, and then like a proc, we have like a proc specifically can keep in a definitionalize, right? Definitionalize, this method just takes in like a proc, and then it fucking saves that proc, like so, right? And then it has a method called a call, right? And then in the call, it does args, like so, and then it passes those args to proc dot, and then does a proc dot call, like and then it passes it args, like so, right? And then basically, yeah, that is exactly how it works. You know what? Let's say r proc, and then r proc is actually just going to hilariously use a proc to do this stuff. So like we can see here that this is a real thing. Let's see. What the fuck? There's no reset arity. Undefined method arity for no class. That's amazing. Wow. Wow. Wow, I fucked shit up. Whoa, that's super cool.
What'd you do to Pry? You broke it.
I broke Pry, dude. That's amazing. I'm really proud of myself. No class. Call. Whoa, there's a call here. Dot call. So in Pry command Ruby, we can actually like jump into this. Isn't that insane? This is a quick thing. If you do option.click right here, you can see where Pry is actually like coded. This is the code in Pry that's being fucked up right now. And so we're in right now the call of an argument, and it says it's on line 613. I'm just showing you some debugging shit right here, right? Correct argument arity, process args. And so def hello, puts hello, and hello. Stack too deep. that's that. Okay, so that is working. Hello, and then puts hi, and then end. You can see I got infinite stack trace error there, if anyone can tell, right? That's because I called the method hello inside the method hello. But okay, so this works. But quit does not work. Quit does not work. Exit does not work. Reset does not work. And so that means these system methods that are defined here, if I did def reset puts goodbye, and then end, this, oh god damn it, it actually overwrites that method. Okay, so that doesn't work. Alright, fuck it. My Pry is totally fucked up. You know what? I don't even know how to...
I don't understand. Wait, how did this happen?
I trust me, I don't understand either. We could find this out. In a normal world, I would actually want us to explore this. But that would just, like, take way too much time.
Was it the name of the class you defined was somehow being used by Pry and we didn't know?
You are fucking smart. That might be it, actually. Let's see. But what did I define? I don't know that
It was class something...
Oh yeah, maybe I did make a class in there, which would be like... Oh, yeah, did I like...
Go back to lecture 2. Lecture 2.rb, did you execute any of that?
No, I didn't. Yeah. Anyway, that's sad. If anyone does figure that out, huge extra credit for you. If we had time, I would definitely want us to like do that. But as you can see, we're not even halfway through this lecture, and so that's really, really concerning that like this may last all night for some of you in Eastern Europe. We will try that it doesn't. let me know if you really have to go. Okay, anyway, so basically with this this proc thing right here, yeah, we could just like do our own proc. So I'm just gonna go in here and like copy that in here, and we have our own proc. Now we can do r proc equals proc dot r proc dot new, and then we can just like pass it a block of code, and then we can do what like puts let's say a b c, and then here we're gonna do like puts hi a plus and b and c like so, and then oh god, did I forget to fucking close that fucking string? I did. Okay, cool. So that's rproc, right? You can see this is an object called rproc right there. And then, you know what? Why don't we try something? Why don't we try something weird? Why don't we do something like rproc.call, and then why don't I pass in like, let's say Anthony, Dalibor, and Lorraine, like so. No method proc for our for no class. Rproc is this. Let's see. No method defined to call proc for a no. Oh, my bad. Shit. Whoops. Hopefully you all understood what went on there. If you don't worry about it. Nothing happened. Okay, cool. So now I'm just going to make this line again. Right here, like so. And then I'm going to do rproc.call, like so. And then, ta-da! It's going to say, hi, Anthony, and Dalibor, and Lorraine. Anyway, so what happened before is I literally just forgot to actually save the instance variable to a proc. But we did that now. And then this is basically how proc works, right? So you can see literally our proc just is it's a proc for a proc, right? It's totally useless, but it basically does what a proc actually does, which is when you make a proc, so we can do exactly the same thing with the real proc, right? Real proc equals proc.new, a, b, c, puts hi, oh fuck it, I'll just copy it. It's better. Like so. If we do real proc.call, real proc call, like so, it's going to do, oh god, fuck me. Right there, it's going to do exactly the same thing, right? And so you can say we literally just made our own kind of proc, right? And it's a really simple proc, right? It was really straightforward. It's really easy. But basically what it does is it just has one method on it, right? That we use. It has lots of other methods, but we only use one method, and it's a call method. And so what does it do, right? Well, when we initialize it, and there are, by the way, multiple ways to initialize this. You can do also this too. You can just do proc like this, and you magically run this thing like this. That also works too. It's the same thing, you could do call on that. Fuck it. I did real proc, like so. Okay, cool. There we go. Hi, Anthony, and Dalibor, and Lorraine, like so. That works fine. Yeah. So what happened here? Well, what we can see is this is just a class. It's a class that basically stores a block that you pass it, and then whenever you call the call method, it regurgitates that block back, right? It takes whatever arguments you pass that call method, and then it passes those arguments to the block of code, right? And then it returns whatever that block of code returns its return value, right? So hopefully that makes sense to you. And so procs, why are procs useful, right? Well, procs are useful so you can do literally things like this, right? You can pass this proc around, right? Because it's an object now that stores your block, now you can just like run around and like pass that proc to wherever you want and like pass it between methods, pass it between things, whatever, right? And then like you can just like do all kinds of cool shit with it. Whereas as a block, you can't really pass a block around, right? What does it mean to pass a block around? You have to like store that block in the proc before you can like do things with it. And so yeah, like basically that's basically any method like rand method. We take in the proc here, right? And then like in here we can do prc.call. And then like we can just do, we'll just do prc.call, right? And then now this method does whatever the fuck we want it to, right? We can pass it one, we can just call it with nothing, and it's going to give us an error, right? Because there was none of that. But if we just called it with like a do, and then we do, in here, we just do puts, hi, end, and so forth, right? And then we call it, well, yeah, that just says hi, right? And so that's basically all that it does. Yeah, now you can just pass this method, a block, and then it will run that block, right, like a proc and so forth. Yeah, so that's what the ampersand is. We already talked about this, so I'm just going in it pretty quickly. If you ever have questions about blocks and procs later, definitely let me know. But yeah, this is a block. This is a ampersand this way. But now, do you all know what the ampersand does the other way around? What happens if I do an ampersand inside a like this? In fact, if I do a let's say, okay, so where's my real proc? Real proc is this. Okay, cool. I have a real proc right here. What happens if I do this? Can anyone tell me what that's gonna give us? You know what? I'm gonna rewrite this rand method, and someone in the meantime.
You're passing real method a block.
What's up?
Are you passing real method a block?
Exactly right. We're passing rand method a block. Exactly right. Yep, that's exactly it. Yep. Okay, so now I'm going to do this. Rand method, and then, can I do this, by the way? What does this give us, maybe? If I do rand method, and then I say real proc.
Want to error out?
Yeah, it would error out. Let me just put in this right here, because I tell it to have these variables. And then, why would it error out? Do you know?
Because you're not using the ampersand.
Exactly. So
pass the block.
So what is the error? The error is yes, exactly right. We're not using the ampersand. And so when we use the ampersand, let's see what happens. Wow, it worked. Great. Does everyone understand that? Why that happened? So basically, the ampersand works two ways, right? When you have a block inside, when you're defining a method, right, and you're specifying the parameters of that method, what things it takes in as arguments. When you use the ampersand, it will it will transform any block that's past it into a proc object, right? That you can then use inside that method, as we see here on lines 15, right? Def rand method, so forth. But when you're invoking a method and you pass it a and ampersand, then it will actually transform a block into a proc. And so now let's do this. Let's rewrite rand method, and let's just say it does ABC in there, okay? And then it does yield ABC, and then if we do this now, can we do this? Can we write this? Oh fuck it, that's not a good example. That's exactly the same thing. Yeah, fuck it, whatever. I just want to show you that this does in fact also work like so. But yeah, rand method, Anthony. This you can see right here we're passing it seemingly 4 arguments, right? We're passing it rand method of Anthony, Dalibor, Lorraine, and real proc. But yet this method only is supposed to take 3 arguments. But it still works somehow. And it works because this is not a real argument. This is actually a block, right? If we just did this, like without that right there, it would give us an argument error, right? It would say raw number of arguments given 4, expected 3. But in this second case right here, we actually, it didn't say that. It still only expected 3 arguments, but it only got 3 arguments, right, on line 19. In fact, this last argument with the ampersand was transformed not into an argument, but into a block. And then the block was just passed in as a block. And of course, any method doesn't have to actually explicitly accept a block, right? It can implicitly accept a block. In fact, all blocks are implicitly accepted, right? If you want to explicitly accept a block, you would actually have to specify that as a as like an ampersand block thing, right? But anyway, so yeah, you implicitly get that block and then you yield it, and then it works just fine. Let me know if you have any questions there. If not, we're going to talk real quick about class versus instance methods. Look how quick we're going. Yay. All right, awesome. So
super quick on the ampersand, there's like ampersand method. So do we, proc, do we never specify?
Hang on. Lorraine, can you mute yourself real quick? You're typing. Okay, awesome, thanks. Dom, what are you saying?
So that means that we pretty much never have to use and because it's always block.
One more time. You never have to use ampersand because
like ampersand PRC. That's a block.
Why do we never have to use that?
Well, if I understood what you said, that we implicitly, like in Ruby, like methods can of code, like always.
Yes. But can anyone think of a reason why we would actually need to do a rand method call with a ampersand proc? Can anyone think of why we would need to do that in some case? Okay, I'll just tell you. Yeah, the reason why you would actually do the ampersand proc is if somewhere you had a proc before. If you would do this, if you had a proc object before that you had captured somewhere that you then wanted to pass as a block to this method. In fact, that is the literal purpose of procs, to be passed around as blocks to other methods. And so basically, like, yeah, you would do this. Yeah, you're totally right? Like, rand method, oh, sorry, there's no end there. Rand method, like, you could do this, right? Like, hello, and then, or just random L or something like that, right? And then, like, in here, do L times L or some shit like that, right? And like that. But what if you were going to do this like 17,000 times, right? What if you're going to like do that same thing? Would you want to just like have to write this again and again and again? Would you want to like just literally have to watch me write this because I'm doing the work? Well, I get really good at typing because I do this so much. So it's actually not that bad for me, but it's worse for you guys because you guys can't type so fast. But anyway, so if you like don't want to do this all day long, right? Well, what else could you do? Well, what you could do is you could capture this as a proc, right? Capture as a proc. And then you could just repeat that proc. And imagine that this is like, 17,000 lines long, right? It's not just like these 2 lines, right? It's actually like this. For some reason, you just want your code, oh, fuck me. If you just want your code to like do this like all day long, right? It's like just fucking so much code, right? And like you really got tired of like copy and pasting all this code again and again and again, right? Then like what could you do? Well, that's what a proc is for, right? Then in that case, you're like, oh god, save me, let me use a proc, right? And then you would do proc.new, or you could just do proc, right? Equals this like huge ass line of code, right? And then you would like save this huge ass motherfucking thing in the proc, and then you would just be able to now from now on this is our awesome proc, right? Fuck it, it's so long. Okay, and then from now on all we have to do is rand method, and then we can just magically pass the proc, right? That's awesome. Well, actually, we should probably save that to proc equals proc.new, and then we can call it like so, rand method proc. Do you see the benefit of using this now and why you might want to use it, Dom?
I understand the proc, like I understand what proc do. Not sure. I meant like there is no reason to. Actually, I'm not sure what my question is, so actually it's okay. But I understand what you're saying. I mean, I understand how procs work, so I'm not sure what my question is. So like we can just.
Yeah, I think your question was like before, if I understood it correctly, was like, should we ever need to use this? We could just like we don't ever need to use this because we could just pass in a block instead, right? Do we ever need to use the ampersand proc thing if we can just manually pass it a block every time instead? The answer is yes, right? Sorry, go ahead. What were you saying?
I meant more, like, I understand that. I meant more, I think I was something about, like, explicitly saying that we need a block here. Like, if we're making a method and we're telling that we need, like, this argument, and, like, this proc, I would never actually need to say that we need this proc because we can just always proc anyway.
Yes, exactly. Yeah. You're that you are totally right. Yes, you can do. That's like the if you do a rand method and here you have a proc, and then you do prc.call, right? This is synonymous again to yes, exactly this, right? Yield, right? These two are synonymous. You don't actually ever have to do this. You're totally right. But the benefit of doing this is that anyone reading your code understands that you expect there to be a block, right? Otherwise, they will never know. There's no way for them to know that there's going to be a block that you're going to use in here until they see a yield, right? And as you all know, like, you think me writing like hash of k plus 1 is tricky. There's no chance you're going to see this, right? So like that is why it's important to be very explicit with your arguments up here, so that people who read your code, including yourself, because you're going to read your code a lot more than you're actually going to write it, understand that that is actually what's expected, right? And that you're going to do something with a block in your code. So it's really just like an explicitity thing, right? It's to make your code more readable, if that makes sense. That cool?
Yep.
Awesome, cool. In fact, that's why App Academy stopped teaching yield, which is unfortunate. They should teach it so people know it. But wait, did you all see yield? Did you see that anywhere?
No.
Yeah, is it like raise?
What'd you say?
Isn't yield like raise?
No, yield is identical to basically proc.call.
It's basically like a proc.
Yield just calls a yield is the exact same thing as proc.call. It just calls a block basically, and then it passes the block whatever arguments you pass. This args, yeah.
Yeah,
args.
I actually gave you a good example in our general chat.
Yes, I'm very proud of you. That was a good example, Dalibor. Great job. You're awesome. Thank you. Cool. Awesome. I'm kidding. That was yeah. You're awesome. Thank you for the good.
I'm sorry. So one more time, what does yield do? It raises the block.
No. There's no such thing as raising a block. Raise specifically raises an error, right? Do you see my screen, Matey? Do you see lines 348 to 350? 352 to 354 are identical to lines 348 to 350. Do you get that? Do you know what proc.call does?
Yeah, it calls a proc.
Exactly. Yep. What it doesn't call proc, right? It actually calls the block that is stored inside a proc, right? And so yeah, go ahead.
So the proc that you're passing in the rain method, proc.call, is calling that specific proc. That specific block.
Okay, yeah. So okay, on line 348 we have an ampersand PRC, right? That captures a block of code that we pass the rand method, and it stores it into a proc object, right? And then when you do prc.call, that call method on that proc then retrieves that block and then runs that block of code with whatever arguments you pass the call method, right? Does that make sense?
Yes.
Okay.
And so, 352 to 354 does the same thing.
Yes, exactly. Except you didn't define this this like proc object, right? There is no proc object, but this works directly on a block that is passed to this method, right? Okay, so let me show you in the code, right? Let's say we do rand method 2, rand method 1, and then in rand method 1 we do let's say we'll call this and we'll do a block, and then in this block it'll just say hi Medi, and then in the second one it's gonna do the same thing. We're gonna do command 2, and then we're gonna do hi Dom, and then right here we're gonna see what happens, okay? And then you know what? Actually, you know what? We can give it some args. Oh fuck it, there are no args. Okay, so let's just remove these args right here. Okay, cool. Alrighty. So let's go in here. Let's just do Ruby lecture 2, and then we'll see there is a traceback error for those undefined local method PRC for main object. Which one was this? This is hi Dalibor and Lorraine. Whoops. Yeah, my bad. Up here. I just have a lot of stupid code that I wrote in this method that I should actually totally delete now because it's totally stupid. And there's just an example. Cool. Awesome. There we go. Okay. So do you see how they did exactly the same thing? So basically what happened is this one, what this did is it captured the block, which is, just puts hi matey, and then it put it into a proc, and then it called that proc object later, which then retrieved this block and then ran that block of code, right? In the second case, what it did was it just captures the block too. This method captures block, and then it just yield just runs the block, right? And then if you do 3 yields, do you have any idea what's going to happen, maybe? Where we can see on the screen.
It's gonna do it multiple times
Exactly
because
right.
they're each a block that'll be executed.
Exactly right. Yep. Perfectly right. Yep. So it's gonna say, "Hi Dom," 3 times like so. Good. Awesome. Perfect. Well done. Cool. Why is it? Why are we running? Oh, random method too. Okay, there we go. I see. Good. All right, cool. Awesome. Hopefully that makes sense. If anyone else has questions, definitely let me know. Cool. Besides that, we're going to talk about class versus instance methods. Anthony, can you tell me the difference between class and instance methods? This is the last big thing. After this, we're basically done with the lecture, even though we still have half the slides to go. I'm just giving you guys some motivation to get through this. Anthony, do you know the difference between class and instance methods? Anthony! Dalibor?
I got this.
Alright, thanks, matey. Real hero.
Class methods are methods that are only executable on objects of a specific class or variables of a specific class, and then instance methods are just methods that can be executed just by calling on them.
Not quite sure what you meant by like class methods can only work on class variables. Is that?
Sorry, I mean class methods. Like, so if you is a class method like what you do similar to monkey patching?
No, monkey patching are actually instance methods. You could monkey patch a class method, but you've never done that so far. Dom, you want to give this a shot?
Yeah, sorry, Ben, I had to step away from a computer for a moment.
Yeah, go for it. You want to do it now?
What was the question again, please?
What's the difference between class method and instance method? You want to define each?
Class methods, okay. Class methods do something to a class itself, and instance methods do something to instance itself.
Yeah, that was a very politically correct answer. Nothing that could really go wrong there. That's good. What do you mean by a class itself? What's a class itself? Well, I make a class here. I'm going to make a class. I'm going to call this dog, okay? All right. So how do I make a class method? Can anyone tell me that?
Like self dot something.
Okay, good. Does anyone know why this is a, let's say this is a bark. Okay, we'll do bark, and then we're going to end this right here. And then we're going to do, oops, there we go. And then here we're going to do another one. We're going to do this bark name, okay? And then we're going to do this, okay. So what is 131? Is that a class or instance method? Dom?
Looking for the 130.
Line 131, sorry, yeah, it's still.
Yep, so that is.
Hello? Hello?
Instance method?
What'd you say? What is it? What is it, Dom?
So is that an instance? One sec, I'm not sure. Self would be Doug. So is that an instance method?
Why?
Not sure.
Why do you think it's an instance method?
I'm just thinking. So if the self bark would be like dog.bark. Wait, actually, dog.initialize is a class method. So
dog.initialize is not a class method. Let's make that clear.
Okay, then I'm not sure. But I'm not sure about the difference.
Cool. Dalibor?
So as per my political explanation, the line 131 should be instance method.
Good, awesome. That's actually not political. That was very objectively true. Good. Why is 131 a instance method?
Because it refers to the instance, like one part of a class.
Yes, we will. Okay, Basically, that is as much explanation as I expect you to have right now. But I hope that you will all come away from this lecture with much more understanding. Does anyone actually understand self yet? Does anyone feel like they got a really fucking good grasp of self, and they really just want to tell the whole class what self is? Anthony, that's you, right? All right. How about maybe?
Oh, I just was completely out of it. I took a break, so I'm gonna have to rewatch this part because I wasn't focused at all. But what are we? So I took like a 10-minute break, but I'll catch up.
Self.bark. Self is the what you're calling this on.
What is
so
self?
In this instance, it's an instance of dog.
Where you mean on line 128?
128 or 131?
Or
sorry, 128. I thought I saw self on 131, but yeah, 128 self.bark.
Yes. What is self?
So an object that's an instance, an object of an instance of the dog object. If you said say you said Ben is dog.new, then you told Ben to bark, you would say Ben.bark. And 128 is that class method.
Yeah, 128 is a class method, but specifically there are two contradictory things you said there. If it's a class method, this self is actually specifically not an instance of the self class. So we're going to do a couple things here, okay? We're going to do puts. We're going to do a p self right there. Actually, you know what? We can do a put self. And then here we're going to do a puts self right here too. And then can anyone tell me what this is going to refer to on line 128 right now? This new line 128. And then can anyone tell me what line 134 will refer to? How about you, Anthony?
So I guess the one on line 128 would refer to a method, a particular instance that we created of that variable. Created like a dog with. It would be whatever we initialized, right?
And what would line 134 refer to?
I don't know.
Cool. Matey? No, you already went. Dom, do you know? What's 128 and what's 134?
The dog, and then the 130, like the instance.
What do you mean by the dog on 128?
Dog.
Yeah, you're right. You're right. It is dog. Okay, I'll let you off the hook. You're totally right. You're good. Okay, so yeah, let's talk about this again. If you may have remembered at the very beginning of this lecture, I said everything in Ruby is an object, right? Everything in Ruby is an object. When I say everything in Ruby is an object, I literally mean everything in Ruby is an object, okay? That means even this class, dog, is a object, okay? That's fucking nuts, right? But it is. Okay, so for example, if I do this, I'm gonna do like in just pry right down here. I'm gonna go and I'm gonna write pry, and I'm gonna do class animal, right? Class animal, end that shit. And then that animal, guess what? Animal has an object ID. That shit is an actual object. That thing itself right there is an object. Animal is an object. What is animal an object of? Let me see. What is this? Superclass or class? Class. My bad. Yeah. Animal is an object of class, which is super nuts, right? So class itself. And what is class? Class is also actually an object. What is class an object of? Class is an object of class. Class is an object of class. Hopefully you understand that. That's trippy as fuck. You're not supposed to understand that. Who the fuck knows what that's doing? But anyway, long story short, class is like some self-referential thing that defines itself and it's itself. But anyway, every single one of these is a class of class. Anyway, so now what if we do this? What if we do doggy equals animal.new. Doggy.class. What is this going to equal, Dom?
Looking. So is that going to be class?
What'd you say?
Is that actually going to be class because it's also a class?
Is doggy a class? What did we do to doggy? What is doggy right now?
I'm sorry. Okay, never mind. So doggy is an instance of animal class. So we're looking for the class of doggy, which
yes. Which would be one more time.
Doggy is an instance of class animal. So is animal.
Perfect. Good shit. You get it. Awesome. Really good. Really good. Yep. That's exactly right. Okay, so now knowing this, imagine that this class thing, when we say class up here, that's actually like saying, here, I'm going to copy and paste this in here, okay? And then we're going to see what this does. Okay, so now this is like saying def, okay? This on line 16, that first line, this class right here, that's kind of like def, right? It's almost like we're making a new method, okay? When you do this, all the code inside here runs, okay? It runs all the code inside here. But what does it run it as part of? Well, it runs it as part of this dog thing, okay? So just like Dom said, on line 128 right here, what the self refers to right now is actually the dog object itself. And what is a dog object? It's the dog object of class, okay? So when I put this end right here, we're going to see something pop up. We're going to see a self equal a dog right there. Do you see that? Put self is dog, so equals dog. And in fact, if we did a p instead, why don't we try a p? Why don't we see what that gives us? I'm going to just write this. Oh, fuck it. God damn it. One more time. Okay, let's see. Right there. And it says dog. Okay, fuck it. You know what? I'm going to do puts, oh, fuck it. How do I get the return value? Inspect should do that. Inspect should give me, let's see, if I do dog. Oh, wait, dog just refers to dog. God damn it. Yeah, that's the problem with inspect. Inspect dog just gives me dog. Okay, yeah, fuck that. Anyway, if I were to do object ID, yeah, let me do that instead. Let's do put self.object ID right there. And then we're going to go ahead and we're going to run this right here, like so. And then you can see that's the object ID, okay? And then if we write dog.object ID, we can see it's the exact same thing. And so now we can see this self right here refers to the dog object. And the dog object is actually just this this class that we made, right? Which is why, incidentally, this self.bark is a class method, right? Why is it a class method? Because we're saying, this is basically like saying dog.bark right here, right? This is literally, we could just like, dog.bark is a class method, right? How do you call a class method? Well, you write dog.bark, right? That's how you do a class method, right? And so how do you define one? Well, you define it the same way, right? You write dog.bark. That's what you define, right? So self equals dog. That's why self.bark equals a class method, right? Because right here at this point in the code, the self refers to the dog object itself, right? And it's making a method on that. And in fact, this is really trippy shit, but there is actually no such thing as like a real class method. It's actually a singleton method. None of you probably know what a singleton method is, but in Ruby, there's a thing where you, and there's a singleton design pattern, which you also haven't gotten to yet. But when you get to there, don't be confused. The singleton design pattern is very different from the singleton method. But a singleton method is an anonymous method. And an anonymous method is something that you can actually make on any fucking object. So this is some trippy fucking shit that we'll do in just 1 second. But right now, let me just define these classes first. So woof. So when you say this, it says woof. And then maybe here we're just going to say put self right there. And put self.objectID. And then we're going to do put self.name goes woof. And then right here, we're going to do attribute reader, right, as you all know. Then we're going to do name right there. And so, cool, awesome. Okay, good. So now let's make this new code do the things that we want to do. So maybe we'll make a Sparky dog.new, right? And then we're going to give it a name, and its name is obviously not going to be Sparky, it's going to be Fido, right? To be really confusing. And then now we're going to go ahead and we're going to do something like we're going to do dog.bark, right? And then we're going to do Sparky.bark name, okay? Cool. And in fact, I'm just going to run this one at a time so you can see what happens. Okay, cool. So now if we do this, boom. Okay, so we see here, we've got these methods that we defined. Now, Dalibor, can you tell me what happens if I say dog.bark? What am I going to see?
Okay, just give me a second.
All right, you took like 10 seconds.
Okay, I don't know.
Oh, you don't know? Is that what you said?
Yeah, I mean, you went way too fast for my level.
Okay. All right. Well, this code should be obvious to you so far. Like, this is stuff that you should know. Like, I'm not doing anything new here, right? Look at lines 1, 2, 3 to 142. Read that, and then the specific like method.
Well, you are. I mean, I saw that you have in line. Well, it's all 32. What is it in 133, right? So you've defined bark, and you have defined that as what are you calling? So you're gonna just put woof.
Yeah, you're totally right. That wasn't so hard, right? Good, man. Awesome. Well, yeah, it's not something like magical. You definitely know how to do that. Just read it. All right, cool. So now I make a new Sparky, right? A new dog. And then if I do, what if I do Sparky.bark? Anthony, what am I gonna get?
So if you do Sparky.bark,
Mm-hmm.
it should be the same, right? You just won't, right?
Nope. Incorrect. Jeffrey, do you know? I've been holding off on you since you really got OOP, so you probably know this stuff. But I'm just checking if you're paying attention now. Jeffrey, you're muted again.
Yeah, no, it just doesn't do anything.
What would we get?
Because there is no .bark method for Sparky.
Oh yeah, you're totally fucking right. If we type it, it actually says undefined method bark per dog. Nicely done, Jeffrey. Good shit. Okay, yeah, so that's right. So yeah, how about this though? Maybe what happens if we do this? Sparky.bark name. Maybe. Yeah, push to talk. Nope.
It will say Fido goes wolf.
Good.
Sorry, it will say.
Nice.
Yeah.
Very good. Awesome. Yeah, perfect. Yeah, that's exactly right. Good. Okay, so then now let's see, what else did it print? It printed out two other things, right? It printed out this like dog thing right there, and then the object ID of it. And then the funny thing is, yes, this interesting dog.object ID is interesting. That's kind of weird. Anyway, Sparky.object ID is this one right here. Yeah, that's weird. I don't know what this hex thing is. Anyway, okay, so basically what happened was, what's confusing to me is that this hex address is different from this this integer address. Though I wonder if we actually just change this hex to an integer address. Bear with me 1 second, people. Let me do this real quick. Let me do dot maybe 2 hex. There's no hex for integers. Okay, 2s16. Fuck it. Nope, that's totally different. Okay, forget what I just did there. Don't ever think about that again. Alright, cool. So anyway, basically with this object ID here, you can see that this object ID right here is exactly the same as what was here. And so in fact, when we have self in here, can anyone tell me what self was inside the bark name method? Dalibor? What did that refer to?
To the function bark underscore name.
No, what does self refer to inside that method bark underscore name?
To the name?
No. Do you have any other guesses? Dom.
To the instance.
Yes, exactly right. To the instance of dog. Self refers to the Sparky object instance of dog that we created, right? And that's in fact why you can see the Sparky.objectID that we literally just write right here, Sparky.objectID is exactly identical to the self.objectID that we printed out on line 139, right? So that's what I want to impress on you, right? Is like these instance methods are methods that are defined on a instance of the class dog, right? And then whenever you call an instance method, the self inside that method is going to be the instance, right, of that object. But inside the actual definition of the class dog, if you type self, you're actually going to get the actual dog object, right, of this self. And then that's why when you write a class method, you do def self.bark, right? Because that is what dog.bark is, right? Dog.bark, the dog right there, the self in here is the dog, right? And so you're saying dog.bark equals that. And so that hopefully makes a little sense to all of you now. But you know what? We're gonna try to really make you understand. Oh shit! Whoa, that's what I did. Oh god, that's interesting. Cool. Anyway, that's not what I did. Anyway, okay, cool. So going back to this, this stuff self.bark shit right here. This is a class method because right here the self is a object of the dog. It is the dog object thing, right? But that doesn't really explain why you can just do this, right? And so why don't we talk a little bit about that? In fact, we're going to do something kind of interesting here, okay? We're going to copy and paste all this again. And then now we're going to talk about singleton methods. And this is something that you would never learn in App Academy or whatever, because I don't think they actually know about this. But in here, what we're going to do is we're going to go ahead and make a new dog, and we're going to call it Sparky. And this time we're going to be nice, and we're actually going to give it a name of Sparky. And then we're going to make a new dog, and we're going to call it Fido, and we're going to do dog.new is Fido, like so. And then what we're going to do is, why don't we do Fido dot bark twice. Okay, we're going to do this. Def Fido dot bark twice. And then puts name self dot name goes woof. Puts self dot name goes woof again. Okay. Did you all see what we did there? That's kind of weird, huh? That's what does that kind of remind you of? That kind of reminds you of what we did right here, right? The self.bark up there. Well, let's see what that does. Does anyone? You've never seen this before, but does anyone want to give a crazy guess what this might do? Dalibor? Dalibor, 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 Dalibor.
Okay. Yep. Let's see.
Dalibor.
Nope. I give up.
All right, Anthony. You shouldn't give up, man. This is like not like rocket science. Like it's actually quite straightforward. Anthony.
We're looking at the code, so it's from like it's just what you have in your pry, right?
Yes, exactly right. Yes, exactly right.
It just print what's in the put statements, like Fido goes woof, and then Fido goes woof again.
That is an amazing guess, and guess what? You're totally fucking right. That's exactly what it does. Why would it do anything else? It probably does exactly what you think it does, right? It's really straightforward. So Dalibor, just like, don't think that you don't know something. Like, you can reason these things out yourself, right? Like, you should at least try to give it a guess.
Right, but I mean, it would be a cheating because as of now, I haven't learned on App Academy Interpolation and hashtag that self.name,
Well,
right?
I
so I learned that on Code Academy because they covered it.
Oh, whoa, so then you, wait, they covered what in Code Academy?
How do you call it? Interpolation, something with hashtag and those brackets.
No, they definitely covered that in App Academy, but that's not even the point of this, right? The point of this is not that string interpolation thing, right? The point of it is the Fido.bark twice method, right? That is what I was trying to get you to like say. What does Fido.bark twice return? The string interpolation thing. Have you all seen that before? Anthony, Dom, Jeffrey, Mady, have you all seen that? Do you know what that is?
Mm-hmm.
Yeah.
Yeah. They do in fact cover that in App Academy. So Dalibor, if you didn't see that, then you missed it somewhere. But anyway.
Yeah.
Yeah. So anyway, yeah, that is the correct way. In fact, I think we talked about this a while back. But yeah, I definitely like told you about this like specifically on a one-to-one call. Anyway, but long story short, yeah, string interpolation is better because it calls the 2s method. We'll talk about that in a second later. But yeah, so basically. What's up? What? Lauren, did you have something to say? Okay, cool.
I might have not.
One more time. Cool. All right. Yeah. So basically, the string interpolation method is like that. That is something totally different. But what I want to get to here too is like this. This is a singleton method that we did, right? What do you see? What the groundbreaking, crazy thing that we did is that we defined the method on a object itself. Hey, Dom, do you know what happens if I do Sparky.bark twice? What do you think?
Would it be a method error? Because we've only defined the bar twice on the Fido.
You are exactly fucking right. We get a method error. Isn't that insane? So basically what we have here is we have Fido, which is a dog, and then we have Sparky, which is also a dog. But now Fido can do methods that Sparky can't fucking do. Fido can bark twice. Sparky can't bark twice. Sparky is a worse dog. Sparky can only bark his own name once. And so that's kind of sad, right? And so like that's pretty nuts, right? And so basically like what we did here is we did a singleton method. Now can you guess why it's called a singleton method? Well, I'll tell you that. It's called a singleton method because it only is on a singleton object thing, right? So it's like it's a single thing, right? So it's a method that's only defined once, right? That's only defined on a single object. And that, in fact, is what a class method is too. A class method is exactly the same thing. Can you tell, like, this Sparky is a object, right? Sparky has an object ID. Dog also has an object ID. We can do this right now. We can do dog dot woof twice. Well, let's do bark twice here too. Oh, that's too confusing. We could do that. Let's do woof twice. And we'll say woof. And then we'll
that wasn't me.
Wait, what? What'd you say, Lorraine? Lorraine, what'd you say?
Didn't say anything.
Oh, okay, cool. Yep, awesome. Yeah, so basically, yeah, we have a dog.woof twice right here, and that is a singleton method that we've made, but it's also a instance method, right? This does woof woof, but we also have dog.bark, right? Which you find in there. And so can you see how those are exactly the same thing? And it's not magic. Again, the whole point of this whole lecture that I'm trying to get here is that these things are not magic. It's not that there's a magic thing called the class method, right? That like just you can only define it in here and it's a special thing that happens there. No, actually you can do exactly that on any object. You can do a singleton method on any object. You can define it on Fido, right? And it does that bark twice thing. And that's exactly what the dog class method is too, right? Is you're just defining a singleton method on that dog class. Does that all make sense, everyone? Let me know if this is like completely fucking confusing and it makes zero sense. But hopefully that gets through. Let me know if I'm talking too fast and none of you understand the single thing I'm saying. But Dom, does that make sense to you?
Yeah.
Sweet, awesome, cool, great. Yeah, if it doesn't make sense to you all, let me know. Yeah, that's basically it. So that's the difference between a class method and an instance method. Is a instance method is defined on instances of a class, and you can call them on that thing, the instances, but you can't call them on, for example, dog does not have a bark name, right? So there's no method bark name on the dog object, right? As you see there. But Fido cannot do bark, right? Because there is no method bark on the Fido object, right? But what a class does, in the class definition, anything where you just do def initialize like so forth, those things are def bark name. Those are defined on objects of that class, instances of that class, whereas anything with a self dot that is actually a singleton method that you're defining specifically on just that object itself. And what do we mean by that object in this point?
I think you recorded something from like before. Hello?
Yep, we can hear you.
Hello?
Yes, we can hear you. Lorraine, did you want to say something? Can you hear us? Raise your hand if you think Lorraine is haunted right now. That's my best guess. Cool. Yeah, I don't know what's going on. But yes, I have recorded things on self before. Oh, that's so weird. Yeah, that's really weird. You are actually haunted. We should get you exercised. Anyway, so hopefully we can solve that problem. Anyway, so going forward, yes, I have recorded something on this before called class, objects, and self, and like what self is and so forth. And so if you've all seen that lecture, this hopefully makes sense to you. But also you're all totally confused when I asked you what self was in like these different places. So maybe you haven't seen that lecture. I'm not sure. Anyway, long story short, hopefully it makes sense to you now. Let me know if it doesn't make sense. But yeah, that's it. These are just singleton methods, class methods or singleton methods that you happen to define on that object itself. And by that object, I mean the actual class object, right? Dog is an object of class, and it is a object that makes instances of its class, right? Super confusing stuff, but hopefully that makes sense. Cool, man. Congratulations. You have now sat through a 4-hour lecture, and we have now gone through half the slides, so you should feel very proud of yourself. Yeah, so now we're just going to talk about Ruby code style. And so now the rest of this lecture is going to go very quickly, because this is just about how to write good code, which is very important. You can see the way that I indent my code, right? This is how you should be indenting your code, right? Everything inside a method definition or a class definition has, like one indent, and then inside there you have another indent for every method inside there. If you have like loops and shit and like things like that, right? If statements and things like that, you do another indent in there, and then you just keep going and like you keep making it look nice, right? This is one good thing about Python, is it forces you to do this. If you don't do this in Python, your code breaks, because whitespace is syntactically significant. That's how it knows that a method has ended, right? In Ruby, it's really nice. Ruby lets you do whatever the fuck you want to do, but that's also not good, because it lets you do bad things, right? And so if you don't have good code style, then your code is bad, because then you can't read your code, other people can't read your code, it's hard to find out where errors are, and like all shit goes wrong, right? So like you have to practice good code style. So we're going to talk a bit about what good code style is. This is from the creator of Ruby. His name's Yukihiro Matsumoto. He says, imagine you're writing email, you're in front of the computer, you're operating the computer, clicking with a mouse, and typing on the keyboard, but the message will be sent to a human over the internet. So you're working before the computer, but with a human behind the computer. Most of the tasks we do are for humans. And so this really talks about the fundamental philosophy of Ruby as a language, right? Ruby is a language written for humans, not computers. And his whole thesis is that most languages are written for computers. They're written with like the computer in mind. What makes things easier for the computer? Is this going to be more fast for the computer? Is it going to be more efficient? Is it going to be like better for the computer to understand? He's like, fuck that shit, right? Like computers work for humans, right? Like computers are our slaves, and this is also the reason why AI is going to kill us all when AI becomes a thing. But basically, he's like, computers are just here for us to like do our work and make our lives easier, right? Our job is not to make the computer's life easier. A language should make a human's life easier. And so computers are our slaves. We make them do what we want, and we should do things that are fun for us, right? So Ruby's whole thesis is, I want to make language programming fun, right? Like, you should have fun when you're writing in my language. And so basically, You are yeah, like Ruby's whole thing is like, it's a joy to like write and like read and so forth. But his other thesis is your preferences are your own, so you can do whatever the fuck you want, right? Like if you want to write code one way, that's totally cool, man. Someone else writes code some other way, that's cool. It's what makes you happy, right? Like deep inside. And so like that's one downfall of Ruby in some ways, and one advantage, right? It depends on how you see it. But like there are many, many, many different ways to do the same thing. There are many aliases for the same method, right? One, there are like you might have seen this in many different places, but like there are different, like you can do this, right? You can do r equals 1, 2, 3, and you can do r.length, and then you can do r.size, and they literally do the same thing, right? They're just two names for the same thing, and it's just like whatever syntactically, semantically makes more sense to you at that point in time, right? Whatever feels right to you, right? Like that's what you do. And so like a lot of this is just like personal style and all that. But the problem with that is that like that may make it such that like no one else can understand your code. It's like if you were born in like Siberia, living by yourself, and like you only talk with like one other person to like speak Russian, your Russian is gonna be like totally fucking different from anyone else's Russian. No one else is gonna be able to understand you, right? The whole benefit of a language is for communication, right? So for you to be able to talk with other people. And that's true of programming languages too, right? Like your code should be written in the way that other people can understand it. It's standardized, right? It's written such that if anyone else, anywhere else in the world who also writes Ruby code reads your Ruby code, they understand exactly what's happening, right? So that's a purpose of a language, basically, right? And so that's kind of important. So don't think of style as like this optional thing, right? Where it's like, oh yeah, like I'll make my style like good, something like that. Like it's super essential, right? You have to do it perfectly well, and like there are right ways to do things, right? That are just arbitrary rules that people came up with. Just like English is an arbitrary language, right? Like who decided like what English is, right? Like just random people over time. But like now there's a rule, right? Like there's a grammatically correct way to speak English and there's a grammatically incorrect way, right? Same exact thing, right? And so you should like do the grammatically correct way of doing things, right? And then during interviews and whatever, right? Like if you have bad style, that's a total experience. Like you haven't worked with other people, right? You don't have like pairing experience or job experience or anything else, right? Like you've just been in Siberia by yourself, right? Like writing code in the forest with no one else, and like no one else can understand you, and so that's a big no-no, right? And yeah, good Ruby code should read like English, right? Just like a language. So some quick naming rules. Variable names are snake case. This is not true for all languages, right? So specifically, let's be aware that we're talking specifically about what's right in Ruby. And so variable names, snake case, what that means is like you see this, you see things like bark name, right? This under this snake case thing, that's snake case, right? It's not something like you don't do in other languages like JavaScript, for example, right? You would do bark name like this, right? With the the camel case thing right there. But that's incorrect, right? Like in Ruby, it's snake case. But however, class names are camel case, right? Like you could do big dog, right? And that's correct for this, right? And you always start this with a capital. A capital letter is how you signify a constant in Ruby, and so that's something to know. But anyway, or not a constant rather, but a fuck, what is it? Like a global variable thing. But anyway, so constants are actually a screaming snake case in that they are, yeah, you get the idea. It's literally screaming snake thing. I may be wrong about what that uppercase thing is. It's just escaping me right now. If anyone else knows, just jump in. Anyway, so yeah, basically this, like these are interchangeable, right? You've seen this before. These blocks right here, right? I can do this, right? I could do, let's see, 5 dot times like this, like I clips I, and then I do this, right? And this works, right? I can do this block curly braces thing on multiple lines, right? But that's just not good code style. Like you should never do that, right? You should do ends for multiple lines. You should do the brackets for one line, right? The curly braces. That's it. Super straightforward. Yeah, use a single line for if and unless statements. If you can, right? Like do the puts truthy, f truthy thing as opposed to if truthy thing, multiple lines, so forth. Obviously, one that's just more efficient code that looks cleaner, but also it's like the good style that people expect when you're writing Ruby code. 80 character line limit. You've seen that I make that mistake. That's what this this thing is for right here, this like little line break you can see. Like I made a big no-no, right? And the big no-no has big consequences because my screen literally ends at this this A character line limit, right? And so if I go past that, then you can't read it, right? And so that's the character limit is good for that reason, right? It's like just keep it so that people don't have to scroll when they read your like code, right? Like it's all on this one thing. It's really important. So like you never should go past that. If you do, also it probably means that you're doing cold golf, which means that you just have like too much going on one line, right? Your lines should never be so long that you have to like write them past an 80 character limit. Interpolation is better than concatenation. And so does anyone know what the difference between these two is? I mentioned it earlier. Jeffrey, do you know? What's the difference between interpolation versus concatenation? So what I mean by that is like string equals, let's say name equals Jeffrey, and then I do...
Yeah, if you do concatenation, you have like 3 separate instances of a string, but if you do interpolation, it's just one with the string in it. Or included.
Yeah.
I don't know how to refer to it.
Yeah, you're right. You are technically right. Yeah. The technical difference is this, right? Like if we did this equals hi plus this, you're right. We are actually adding 2 strings together, right? And then those 2 strings are using a plus method to add strings, right? So there's a plus method defined on strings. And this is something that we'll talk about. You know, if we had more time, I would talk about the syntactic sugar behind that. Of like this plus method is literally the same as this, right? Name. So can you see how that just worked? Can anyone explain to me what I did there? Dom, line 4.
It's like just loading that. Is that like the? I mean, it's probably going to be something like where it adds. Like I've never seen this, but like it's probably like similar to like plus equals or something.
Nope. In fact, you should already know what it does because it does.
Like, I mean, like how like the method that it works with.
One more time. Sorry.
It's not going to be like literally plus equals, but I'm not sure. Like I've never seen this thing, and I'm not sure.
So why don't you logically think about it? What does a dot do? What does a dot do in a...
Okay, so it's a string. So it's a string. So it's a method to the string, and then what we're passing is the name.
Exactly right. And what does it seem like it's doing with that?
So it's like the line above that, but just as a method.
And so what can you guess? Like, do they seem like they're doing exactly the same thing?
Wait, what do you mean? Like, so it's like, how does the inside look?
Does line 3 and line 4 seem like they're doing exactly the same thing?
So what's the question? Is the question like, how does the line 4 look inside of the method?
Okay, line 3 is string equals hi plus name, right?
Yeah.
Line 4 is the string hi dot plus parentheses name, right?
Yeah.
What's the return value of both those? Is it exactly the same?
Well, yeah, since we ran both, they returned the same thing.
Yes. So could they in fact be exactly the same thing?
Most likely.
And if they are, what is that kind of called?
You're talking about like object IDs?
No. Okay, you got pretty close. Sorry, I'm just like grilling you. Yeah, no, it's syntactic sugar. That's what I'm trying to get at. Like line 3 is literally just syntactic sugar for line 4, right? Like that is literally the same thing.
Yeah.
Yeah.
Oh, okay. Okay.
Yeah, just like plus equals, right? Like plus equals is syntactic sugar, right? For equals string plus like name, right? Like this is just syntactic sugar. Like, this, again, nothing is magical in Ruby, right? This plus here is not like some magical thing that's like custom defined on string, right? It's in fact just, it's a method. It's a method. You can define it yourself, right? We can fucking monkey patch this method, right? Why don't we fucking go into string and let's do something really fucking stupid, which you should never do, right? And then we'll do def plus, and then we're going to do def plus takes in arg, and then string, it takes in string, and we're just going to do hi Dom in here, and then we're going to end that, and then we're going to end that. And then now let's do this again. Let's see. What do you think this is going to give us now? Oh, fuck it. God damn it, it just broke everything. But before it broke everything, it did do something nice, which is cool. Oh, I see, I see. Yeah, that's funny. Yeah. Why did it... oh, interesting. What did it say? It said nil for undefined method, length for nil class. Interesting. So it calls the length method somewhere. Anyway, we can see what happened is like we threw a massive fucking error because we literally oh fuck it, god damn it. No, that's not what I exactly wanted to do. This is what I wanted to do. Let's try this. Let's go and do a right. It's nil. That's why I did that. Yep. Okay. Cool. So what we're gonna do here is we're gonna do a string, and we're gonna do this equals what we're gonna do name equals dom, and then we're gonna do.
Would it be self dot plus?
No. That was the correct thing. But you can see it did actually say Dom. I just wanted to say something else here. So let's do name as Jeffrey here, and then we're gonna do string equals hi plus name. No, hang on. We're just gonna do a class string, and then in here we're gonna do def plus, and this is gonna take in another string, and then in here we're gonna do we're not gonna do that. We're just gonna return Dom. We're going to return hi people. Let's do that. Let's see if this actually works. I'm just kind of curious. And then we're going to do this, right? We're going to do hi plus plus name. What do you think this is going to return? Anyone? Maybe?
It's going to return hi Jeffrey.
God damn it. It thinks people is an object. Undefined local variable or method. Oh, my bad. Oh, hi people. Oh, wow. That's so cool. Look at that. Wow. Yeah, hand. No, wait, what the fuck? What did I write? Did I write, hi? Whoa, that's
single.
nuts.
Single curly. Single.
That is super cool. Did you see that? So I write this like that, and then it fucking goes ahead, and then it says undefined. Oh, people. Oh yeah, thanks. Name, undefined. Whoa, that is super nuts. So it did some crazy shit. Let me monkey patch this again. Def. Wait, crap. Oh god. Okay, so this is why you should never rewrite these things, because you will break literally. Monkey patching is actually really dangerous. You should usually not monkey patch things. That is like really, really bad. And hopefully you can see why it's bad because of what's happening right now. But I'm gonna do it anyway, just so we can get to the, something that might work. I'm gonna actually return a number instead and see if that does something differently. It may actually still break everything. Jeffrey. And we're gonna do class string, and we're gonna do def plus thing. And we're going to return 1. We're going to end that, and then we're going to do hi, like so. Nope, okay, that breaks it all. Everything breaks. Undefined method length for integer 1. That is super cool. Yeah, so basically behind the hood, what's happening is this plus method is actually called for many things. But what you can see here is like, see when I try to do this now, when I did like, like string plus something, it actually does call this method, right? In fact, when I overwrote this method in the string class, it broke everything, right? So that's somewhat what I was trying to get to the point of, is that like this thing is not magic, right? Like string name equals dom hi plus name is literally calling this method, which is exactly the same thing as this, right? This hi plus thing is syntactic sugar for this, right? These are literally the same, right? It's hi. This thing is calling this plus right here is a method, right? It's a method that's defined on string objects. It's an instance method of string objects, and you pass it an argument, right? And then it concatenates those two things together. And so here's where we get an error, right? Can we do this? Dalibor, what does this give us? If I do hi plus 5. Dalibor.
Error.
Awesome, yeah, you're totally right. It gives us a no implicit conversion of integer into string. Can you see why? It's because we're doing this, right? We're doing plus 5 right there. And we get that exact same error, right? If we do it like that, you can see what's happening is it's actually trying to add the 5, which is an integer, to string. And that doesn't work, right? You can't add a string to an integer, right? Like, what does that mean, right? But you can see it's actually trying to add the integer into a string, right? So it's actually a method that's defined on the string class, and then it's being passed an integer as an argument, like right here, and then it's trying to add them together. Hopefully that makes sense. How about this? Anthony, do you know what this gives us? If I do this instead, like so. Hi, and then I interpolate 5 in there. What am I going to get? Am I going to get an error? Am I going to get something else? Anthony? Anthony!
I think you're gonna. I don't think you're gonna get an error. I think you're just gonna get a string with both those in it, because I think the interpolation converts it to a string, right?
You're exactly right. Really good call. Do you have any idea how it could possibly convert that into string? How would Ruby know how to turn an integer into string? We've talked about this already in this. I gave you a hint.
I don't really know.
That's cool. Yeah, so basically every method, every object, every class in Ruby, and in your own classes, you'll see this over time, has a .2s method, basically. You'll need to write these yourself, a .2s and inspect. Everything over has an inspect because inspect is inherited. 2s is also inherited, actually, I think. But anyway, long story short, you can write your own 2s and all that. But yeah, this is what this is basically doing is it finds that interpolation, and then it does this. It calls 2s on it. And then, so we can actually do that ourselves, right? What does this give us? Dalibor. Any idea?
Let's see. Same thing?
What do you mean? Like, what's the same thing?
Like the previous line?
Yes, exactly right. So you can see, what does 5.2s give us? It gives us a string representation of 5, right? So that's fantastic. And so, Mady, what does this give us? If we do hi plus an array of 1, 2, 3.
You're gonna get an error now?
Good call. Good call. And then, what if we do this? What are we going to see? If we do hi plus array 123.2s.
It's gonna be hi one array one. It's gonna be a string, but it's gonna be hi 1, 2, 3.
You're
like
exactly
brackets.
right. Perfect. Good. And last one here. What if we do this in here and we do the string interpolation, and then we do hi, and then you know, the 1, 2, 3 in there. What are we gonna get now? Maybe.
I don't know. Hi plus 1, 2 array 1, 2, 3.
Exactly right.
But as a string.
Yep, exactly right. And so basically what this string interpolation does is it magically does this like 2s for you, right? And so that's why it's a little bit more powerful, right? Actually, you know what? I literally wrote this in the page in the lecture notes. You can see that interpolation also implicitly calls the 2s method on all the non-string objects that are interpolated instead of throwing an error like concatenation does, right? There you go. It's there. It was on the screen the entire time. If you read that, you could have seen it. Yeah, that's basically it. Cool. So basically, let's see. How about this? What is this gonna do? Anyone know? This is a dirty trick question. Jeffrey. Jeffrey, you're muted again. You're always muted. You're still muted.
All right. I think that would just print 1, 2, 3.
So that actually prints.
Oh wait, are those?
What's up?
Yeah.
Yeah.
Sorry, that would print exactly what it says.
Yeah.
Yeah, because it's got the little char brackets around it. I was trying to say earlier, I think when you're monkey patching, if you put those brackets around your return statement, it might have worked.
So oh yeah. No, I think the plus method actually returns something that fundamentally the array class, the string class needs, which I totally fucked up by like returning an incorrect thing that it doesn't want, or it does something. But we can look into that later. But yeah, here you can see basically you cannot actually string interpolate with single quotes. String interpolation only works with double quotes. That's kind of the point that I want to get to. And so basically, yeah, if you want to string interpolate, just remember to use double quotes. In general, double quotes are better than single quotes. You can do more things with double quotes than single quotes. This is something that got me. Here you'll get an error, right, because that's not defined. But if you do name, like we define name up there, hi Dom. Yep, so anyway, that's the quick thing there. That's it. Good stuff. Okay, moving on. So then we have, you do a bane for mutating methods, and then you do a question mark for Boolean methods, right? So this is just a stylistic thing, but again, like I mentioned earlier, if you're going to write a method that mutates the argument, you have to make that extremely clear. If you're going to mutate the argument that you pass in, you make that clear by actually like putting a bane at the end, right? So let's say we have an R and we set it equal to 1, 2, 3, right? And then we do r.map, and then in that map we do L, and then in the L we do L times 2, and then we do that. Then we get 4, 5, 6, right? But there's, let's say, Dalibor, what is R right now? Oh shit, Dalibor just disappeared. Dom, what is L right now? Or what is R?
It's 3 since we didn't like make it, like we didn't mutate it.
Exactly right. Yep, perfect. Awesome. Now, Anthony, what is L now after we do this? On line 23, give it like 2 seconds. There we go.
Oh, it would be 246 because we used the other map version that mutates the array.
You are exactly fucking right. That's perfect. Yep, and that's exactly what you should do with your own methods too. When you make methods, if they mutate the argument that you're passing it in, you should have a bane sign. And even if it's not a monkey patch method, even if it's just like a normal method here, right? Even if it is like this, arg, even if not monkey patched, if it mutates the arg, you should have a bane at the end. Okay, cool, that's it. And then, yeah, for Boolean methods, if your method returns true or false or something like that, right, put a question mark at the end of that. Should be pretty explanatory. Again, stop me at any time if nothing makes sense to you and everything's so confusing and the world sucks. But besides that, what we have here is the next one. Use explicit block parameters over yield. So, you know, we talked about this already. That way you know if a block needs to be passed into a method. That's it. Cool, super straightforward. Cool. All right, no code golf. So I mentioned this term a little bit earlier, but basically, code golf is when you like just do so much fucking shit on one line, right? And like it's all fucking like confusing, and like nothing makes any sense, and like you no one can fucking read this shit, right? Like who knows what the fuck this is doing, right? And so this is bad. Don't do this. Make your code really readable for your own sake, because you're gonna be reading your code a lot. And if it's bad, then it's bad, and you're not gonna understand anything, and life is gonna suck. The end. Cool. Use proper indentation. Again, this is what I'm saying, right? If you don't do this, and I've seen you do this, Jeffrey, a lot, for example, so like definitely get better at this. Like, can anyone see where the bug is here? Jeffrey, can you see the bug here? Jeffrey, you're muted.
No,
No, it's a.
Exactly. That's the point. That's the right answer this time. Is I don't know the answer, because it would be ridiculously hard to find the answer, right? But if you indent it correctly, now it's super easy to like see where there might be an error and so forth, right? And so like this is so much more easy, right, to see. In fact, like immediately it should pop out to you all, like if you just go inside out, right? Like 11 to 14, they've got that end right there. Until doesn't seem to have an end. That's weird. Let's see that other until. So the 9 doesn't seem to connect with anything. The 7 and the 16 seem to connect. The 5 and the 17 seem to connect. Then the 1 and the 19 seem to connect, right? And so now it's really easy to see, right? The error was that like inside until, right? Can you see how it's fucking impossible when you don't have indentation? And when it is indented, it's really easy to tell, right? And so like, yeah, like please indent your code. If you have bugs and your code is not indented, that is totally your own fault. And cool. It's also super apparent if someone's inexperienced if they don't indent their code correctly. Embrace it. Take the time to get it right. Now it'll be worth it. Cool. And then name your variables well, right? Like, does anyone know like what this code is doing? Has no idea what the hell this code is doing, right? Because like, what the hell is F? What the hell is S? What the hell is X? What is like Y? What is F? What is V? What is A? Whatever. But if you do this, then it's really clear, right? If you name your variables well, you say, oh, obviously, okay, so we're taking in a prompt, and then we're taking in an answer, right? And then we have input, and then until the input equals answer, I see. Okay, so we're basically guessing here, right? So we know what the right answer is, and then we know what we should ask them as a prompt, and then we'll just wait until they get the right answer, and then until they get the right answer, we'll just keep doing this method, right? So you can see how, like, just by naming your variables, your code goes from, like, indecipherable to, like, perfectly English readable, right? So that's it. Cool, awesome. So let's do a quick recap. Adhere to case conventions, again, for the variable names, class names, constants, etc. Use do-end blocks for multi-line blocks, and use these curly braces for the single-line blocks. If you can, keep an if or unless statement to one line. Then, yeah, just keep it to one line. Keep your lines shorter than 80 characters in general. Interpolation is better than concatenation. Plus, use the bane for the mutating methods. Use question mark for Boolean methods. Use proc.call to be more explicit over yield. Name your variables so your code reads like English. And these rules will differ by language, so stick to the conventions for the language that you are using. You are using Ruby now. These are the rules for Ruby. Congratulations! You guys all went through a 4.5-hour lecture. How do you all feel?
Hey.
Woo.
And this was really a lot of stuff.
Yeah.
I'm dead.
For all. Man, yeah. Can you imagine? This is all the stuff that they give you just for the second day, and then you're supposed to go out and program for another like 5 hours after this, or 6 hours or some shit. But yeah. How do you all feel right now? Where are your energy levels? I know I'm kind of exhausted.
I feel better now, but I took a break that I probably shouldn't have.
No. You definitely should take a break. In fact, that's really good feedback. I am going to do that from now on. In App Academy, they do give people breaks for this exact reason. Because, like, this is a fucking marathon, right? Like, to, like, be fully 10 out of 10 on this entire time is, like, nuts, right? It's, like, it takes a lot out of you. So, my bad.
I'm going to have to go back for, like, the hour before I took the break because I was completely out of it. But at least it's on YouTube, so I'm going to do that after I take a break now. I'll do that tonight.
Yeah, that's my bad. Yeah, in the future, remind me if I don't give you guys breaks, like, every hour or something like that. Because otherwise, like, and if any of you just, like, feel like you're flagging, let me know, and then, like, we can take a break, right? Like, I want you guys in here to be on, like, 10 out of 10, as opposed to, like, just, like, really flagging and all that. Please give me feedback on this afterwards. Like, did everything seem to make sense? Was anything not clear? Was it helpful? Did you learn new things? Did things that didn't make sense before make sense now? How do you all feel about this? Dom?
Yeah, sure. I think it was insane. Like, super cool. Yeah.
What was? Sorry.
I mean, like, that it was insane, like, in a good way. Like, it was, like, super, super cool. Yeah, and I could, like, do these, like, every day, but, like, obviously, well, like, it's just, like, so much, like, it's just so good. It's, like, awesome. Really, really cool. And, like, I've learned Yeah, I just feel like I really understood a lot of stuff more in depth. Just like as you said, like just understanding what's under the hood.
Awesome. Thanks,
Super
dude.
helpful. Super, really awesome.
Thanks, dude. That means a lot. Yeah, I really hope that it is. Yeah, again, like, please, like, I really appreciate when you do, like, interrupt and, like, ask questions and all that when you don't understand things. Otherwise, like, there's no way for me to know, right, if you do understand. Except when I call on you and none of you know the right answer, in which case I'm like, oh god. But, yeah, so hope it is helpful. Notes for myself is I will take breaks in the future. We may try to actually, like, split these lectures up if they take too long. We might do the same thing as a daily stand-up, so we'll just say, like, hey, this lecture will be like 2.5 hours at most, right? Or 2 hours, and then if it goes longer, we'll just like do it on the next day. But yeah, if anyone else has any other ideas, like please hit me up anytime. Maybe how'd this feel to you? Did everything kind of make sense?
Yeah, it wasn't bad. It was pretty good. It was better than Av Academy, but I think biggest thing is we've got to do like a lecture first half, 15-20 minute break, lecture second half.
Yeah, exactly. Yeah, you're totally right. Yep, my bad for missing that. Cool. Jeffrey, how'd you feel?
Pretty good. I was really familiar with a lot of this stuff, but there was some good nuggets in there.
Yeah, you really knew your shit, which is really awesome. So I feel like, yeah, you're like, whatever you're doing is working great. So keep that up, man. Really good job.
Mm-hmm.
Cool. Anthony?
Thanks.
I think there's no sound.
Oh, yeah. Damn it. Anthony? You're muted?
I thought it was really good. I need to review the procs stuff a little bit more, but in the self. But I think I'm pretty good at the other stuff. Like I understand the references and the other stuff pretty well, but obviously the styling. But I'm gonna go back through, try to do blocks. Like I learned a lot, but there's definitely I could learn it better. But I don't have any specific questions right now. But I'll probably hit you up with some later.
Sweet. Thanks, man. Lorraine, was this helpful for you? Was this a total waste of time for you?
I think I learned some things, like, definitely about the Singleton. I didn't know about that before. Just, like, basic Ruby syntax.
Sweet, awesome. Yeah, thanks. I'm like, I really appreciate you all, like, staying so long and, like, doing all this. It was definitely a lot of stuff. Okay, so in the future, please keep me, like, if you're all flagging and I haven't, like, given you a break yet, like, I ride you guys like slaves, right? So, like, tell me to, like, give you guys breaks. That would be good. If there's anything else that would be helpful, please give me feedback on any way that this could be improved in the future. Otherwise, besides that, please enjoy the rest of your lives. Thank you so much for the lecture. See y'all soon.
Love you, bud. Talk to you later.
Talk to you later, man.